Good evening and welcome. Settle in. Let the lights go low, let your shoulders drop away from your ears, and let your breathing find the slow, unhurried rhythm it keeps when nobody is watching. Tonight we are going down, not quickly, and not far in any direction that would tire you, but slowly and steadily, the way a single flake of white sediment drifts from the sunlit surface of the sea toward a floor it will not reach for weeks. That is the pace of this journey. There is nothing to be afraid of down here. Nothing in this story is going to jump at you, nothing is going to lunge out of the dark, and nothing is going to ask anything of you at all. The deep ocean is in truth the calmest place on this planet. It has no weather, it has no seasons worth mentioning, it has no thunder, no wind, no sudden change of any kind. It has been doing the same slow, patient blue-black thing for a very long time, and it will keep doing it long after you have fallen asleep tonight, and long after you have woken tomorrow and forgotten most of what you are about to hear. That forgetting is allowed. That is rather the point. Over the next while I am going to tell you 100 gentle facts about the deep ocean. They are numbered, so that you always know roughly where you are, and so that you can let go of the counting entirely if you would rather. If you drift off at fact number 9, that is a success. If you make it to fact number 100, that is a success too, and you will have travelled from the last of the sunlight to the bottom of the deepest trench on earth without once getting out of bed. To give the journey a shape, I want you to imagine a small ship. She is called the Corvina, and she is not a large or glamorous vessel. She is a working research ship, white paint gone chalky at the rails, an orange crane at her stern, a galley that always smells faintly of coffee and diesel. She is holding station tonight over water that is nearly 5,000 metres deep, which is to say that beneath her keel there is more empty vertical distance than there is between most people and the nearest mountain top. On her afterdeck, under a floodlight the colour of warm butter, a submersible sits in its cradle. It is a small white sphere inside a yellow frame about the size of a delivery van, and it is called the Thessaly. Its pilot is a woman named Inez Marchetti, who has been diving for 11 years and who still, every single time, feels the same small lift under her ribs when the hatch closes. Beside her at the rail stands a young deckhand named Priya Anand, who joined the ship 4 months ago and has not yet stopped looking over the side at night, and in a warm cabin one deck up, wearing headphones, a quiet acoustics technician named Tobias Lund is listening to the sea and writing down what he hears. We will visit them now and then as we go, not because anything dramatic happens to them, but because it is pleasant to have a small lit ship on the surface while we drift downward, and because it is good to remember that everything we know about the deep, we know because somebody patient went and looked. So, the floodlight hums. The water below the ship is black and glassy and moving very slowly. Somewhere below, a great many creatures are beginning their nightly climb toward the surface, as they do every evening, everywhere in the world at once. Let us begin. Fact number 1. The deep ocean does not begin at the bottom. It begins at the moment the light gives out, and that happens far higher than most people expect. Oceanographers usually draw the line at 200 metres below the surface, which is roughly 650 feet, or about the height of a fairly ordinary office tower stood on its end and dropped into the water. Above that line there is enough sunlight for plants and algae to photosynthesize, and so the upper ocean is a place of growing things, of green and blue and gold, of drifting meadows too small to see. Below that line, photosynthesis fails. Nothing green can make a living there. And so, in a single soft transition that has no wall and no door and no sound, you pass out of the part of the ocean that feeds itself with sunlight and into the part that must be fed from above. That boundary is not sharp. It moves. In clear tropical water, the light reaches deeper. In water thick with plankton or river silt, the deep begins much shallower, sometimes only 50 or 60 metres down. It is less a floor than a slow dimming, like a room at the end of a winter afternoon when nobody has thought to turn on a lamp yet. Fact number 2. The ocean is, on average, about 3,700 meters deep. That is roughly 12,000 feet, or a little over 2 miles. It is worth sitting with that number for a moment, because the picture most of us carry in our heads is of a shallow blue rim around the continents. In reality, the shallow rim is the exception. Most of the planet's water is deep water, cold water, dark water. If you could somehow smooth out every trench and every ridge and every seamount and spread the ocean evenly over the whole surface of the Earth, land included, the world would be covered in a shell of seawater about 2.5 kilometers thick, with the tallest mountains buried and forgotten under it. The Earth is not a world with an ocean on it. The Earth is an ocean with a little dry ground poking through. Fact number 3. Because the ocean is so deep, and because life exists at nearly every level of it, the deep sea is by a very wide margin the largest living space on this planet. Estimates vary depending on how you measure, but the usual figure given is that the deep ocean makes up more than 95% of all the habitable volume on Earth. Everything you have ever seen with your own eyes, every forest, every grassland, every city and coral reef and garden and pond. All of it together is a thin rind on the outside of a very large dark room. When people say the deep sea is unexplored, they are not describing a gap in a map. They are describing almost the entire house, with a single lamp lit in the hallway. Fact number 4. The first layer of the deep is called the twilight zone, and it is the gentlest of them all. It runs from 200 meters down to about 1,000 meters. Scientists call it the mesopelagic, but twilight is the better word, because there is still light there, just not enough to live on. If you were floating in the twilight zone at midday and you looked straight up, you would see a soft blue glow, faint and even, like the last of the evening through a curtain. Look sideways, and you would see nothing at all. Look down, and you would see a deeper blue going to black. It is a strange, beautiful, half-lit place, and it is where the great majority of the deep ocean's fish actually live. Fact number 5. Below 1,000 meters begins the midnight zone, the bathypelagic, and it runs down to about 4,000 meters. Here the sunlight is completely gone, not dim. Gone, no instrument has ever detected sunlight below about 1,000 meters, and even that is a technicality involving photons so scarce that they arrive one at a time. In the midnight zone, every single scrap of light comes from living things. The water is cold, around 4 degrees Celsius, and remarkably still. This is the largest single habitat on the planet by volume, and it is a place of soft, sparse, occasional light in an enormous slow darkness. Fact number 6. Below 4,000 meters and down to about 6,000 meters lies the abyssal zone. The word comes from the Greek for bottomless, which is a lovely piece of ancient exaggeration, because the abyss very much does have a bottom, and it is one of the flattest and quietest surfaces anywhere in the solar system. Abyssal plains cover a large share of the ocean floor, and they are covered in a fine pale ooze made of the skeletons of microscopic creatures that lived at the surface and sank when they died. Walking across an abyssal plain, if you could walk, would be like walking across a snowfield that has been falling gently for 60 million years. Fact number 7. Deeper still, in the long narrow cracks where one piece of the Earth's crust slides beneath another, lies the Hadal Zone. It begins around 6,000 meters and reaches down to nearly 11,000. Hadal comes from Hades, the underworld of Greek myth, and the name is more atmospheric than it deserves, because these trenches are not fiery or violent. They are the coldest, stillest, most patient places in the sea. There are only about 30 of them worldwide, mostly ringing the Pacific, and together they make up a tiny fraction of the ocean floor while containing some of the strangest and most self-contained communities of life we know of. Fact number 8. The deepest of them all is the Challenger Deep, a small elongated hollow at the southern end of the Mariana Trench, in the western Pacific. Its floor lies about 10,900 meters below the surface, which is a little under 36,000 feet. To put that in a shape you can feel, if you took Mount Everest, all of it, and set it down in the Challenger Deep, the summit would still be more than 2 kilometers underwater. You could sail a ship over it and never know. More people have stood on the summit of Everest in a single busy morning than have ever visited the bottom of the Challenger Deep in the whole history of our species. Fact number 9. We have better maps of the surface of Mars than we do of the floor of our own ocean. And this is not a figure of speech. Spacecraft can photograph an airless planet directly. Seawater blocks light and radar alike, so the seafloor must be measured the slow way, by ship, with sound. For decades, the global map of the deep was assembled mostly from satellite measurements of the sea surface, which bulges very slightly over underwater mountains and dips over trenches. A beautiful trick that gives you a blurry picture at a resolution of several kilometers. Only about a quarter of the seafloor has been mapped at modern high resolution, and an international effort is slowly, patiently filling in the rest, one ship track at a time. Fact number 10. The pressure at the bottom of the deepest trench is a little over 1,000 times the pressure you are lying in right now. At the surface, the air presses on you with about 1 atmosphere, and you have never noticed it once in your life. At 11,000 meters, the water presses with more than 1,000 atmospheres, which is roughly the weight of a large family car balanced on every square centimetre of you. And yet, and this is the part people find surprising, the animals down there are not crushed and do not feel it. They are made mostly of water, and water does not compress much. There is no bubble inside them for the pressure to squeeze. They simply live there, the way you live at the bottom of an ocean of air, entirely unbothered, entirely at home. On the deck of the Corvina, the crane has swung out over the water, and the Thessaly is hanging above the sea, turning very slowly on its cable, dripping. Ines Marchetti is already inside, sitting cross-legged in a sphere barely wider than she is tall. Checking switches she has checked 4 times already. Priya Anand has one hand on a tagline and is watching the sphere's little round window catch the floodlight. In a moment, the submersible will touch the water, and the black surface will close over the yellow frame without any ceremony at all, and the descent will take almost 2 hours. That is a long time to fall through nothing. Ines has said that the first 20 minutes are the prettiest, and the rest is like riding a very slow lift through a building with no floors. Let us go down with her and talk about light. Fact number 11. Seawater does not swallow all colours at the same rate, and this is the single most important thing to understand about light in the ocean. Water absorbs the long wavelengths first. Red is the longest wavelength we can see, and red is the first to go. In clear ocean water, red light is essentially gone by about 15 meters down, which is barely deeper than a swimming pool is long. Orange goes next, then yellow, then green. Blue and violet, being short and quick and stubborn, travel the furthest, which is why the deep sea is not black at first, but a deepening, saturating. Endless blue. Divers know this trick well. If you cut your finger at 30 meters, the blood does not look red. It looks dark green or grey, or simply like a smudge of shadow leaving your hand, because there is no red light left down there for it to reflect. Bring the same finger up into the sunlight, and the colour comes back instantly. Nothing about the blood has changed, only the light has. Ines has described the descent as watching the world's slowest sunset, one that starts gold, turns green, turns turquoise, turns cobalt, turns navy, turns indigo, and then simply keeps going darker without ever changing hue again. Fact number 12. Below about 1,000 meters, there is no sunlight at all. Sensitive instruments lowered into the sea have measured the very last stragglers of daylight at around 800 to 1,000 meters in the clearest water on Earth, and below that the reading is simply 0. Not faint. 0. And here is the part that is worth holding on to as you drift off tonight. That means the majority of the ocean, by volume, has never once experienced a sunrise. There is no day down there, and no night, no noon, no dusk, nothing to mark that the earth has turned. A creature born at 3,000 meters will live its entire life in conditions that do not vary from hour to hour or from season to season. The upper world's great drama of light and dark, which organizes nearly everything that we do, simply does not reach it. And yet, as we will see, the deep is not without light, it is only without the sun. Fact number 13. Light in the deep ocean is made by the animals themselves, and this ability, called bioluminescence, is so widespread down there that it may well be the most common form of light production on the entire planet. Surveys carried out with cameras off the coast of California, counting every animal that drifted through the frame from the surface down to 4,000 meters, found that around 3/4 of all the animals seen were capable of making their own light. 3/4. It is not a rare trick or a specialist adaptation. In the deep sea, glowing is normal, and not glowing is the unusual choice. Jellyfish glow, shrimp glow, squid glow, fish glow, worms glow. Single-celled creatures too small to see individually glow in such numbers that a passing ship can leave a wake of cool blue fire behind it. If you could take all the light-making organisms in the ocean and switch them on at once, the sea would outshine every city that has ever been built. Fact number 14. The light itself is cold, and it is made by chemistry rather than by heat. The recipe is beautifully simple and has evolved independently, by the best current count, something like 90 or 100 separate times in different branches of the tree of life. You need a molecule called a luciferin, which is the fuel, and an enzyme called a luciferase, which is the spark. Bring the two together in the presence of oxygen, and the luciferin is oxidized, and the energy released comes out not as warmth, but as a single photon of visible light. That is all. No filament, no flame, no waste heat to speak of. Our own light bulbs, even the good ones, throw away energy as heat. A shrimp making blue light in the midnight zone is close to perfectly efficient, converting almost all of the chemical energy directly into light. The names are unexpectedly poetic for a piece of biochemistry. Luciferin means light bearer. Fact number 15. Most bioluminescence in the ocean is blue, and there is a very good reason for that. Blue light, as we have already established, travels furthest through seawater. If you are going to spend precious energy making light, you want that light to carry, and so, over and over again, in unrelated creatures separated by hundreds of millions of years of evolution, the sea has arrived at the same shade, a clean, cool, slightly violet blue, somewhere around 470 nanometers in wavelength. It is the blue of a gas flame, or a phone screen in a dark room, or the last light on a winter evening. Almost every eye in the deep ocean is tuned to see precisely that colour and very little else. Whole visual systems have simplified themselves down to that single narrow band, discarding colour vision entirely, because in a world with one colour of light there is nothing else worth seeing. Fact number 16. Perhaps the loveliest use of light in the deep is a trick called counter-illumination, and it exists to solve a problem you would never think of. In the twilight zone, where a faint blue glow still filters down from above, anything swimming between a predator below and the surface above appears as a dark silhouette against that glow. It does not matter how well camouflaged your back is. From beneath, you are a shadow. So a great many Twilight Zone animals, particularly small squid, lanternfish and hatchetfish, have covered their undersides in rows of tiny light organs, and they glow gently downward at exactly the brightness of the water above them, erasing their own outline. Some can adjust the intensity as the sunlight overhead changes with the hour and the weather. Some even adjust the colour. A hatchetfish is a small silver coin of a creature with an upturned mouth and enormous eyes, and its belly is lit like a row of street lamps, so that, from below, it becomes a fish-shaped hole of exactly the wrong shape to notice. Fact number 17. A few deep-sea creatures use light as a private language by making a colour almost nobody else can see. Down in the midnight zone there are fish, most famously the loose-jaw dragonfishes, that produce deep red light from an organ just beneath each eye, like a pair of small headlamps. Red light, as we know, does not travel far in water and is invisible to nearly every deep-sea eye because those eyes long ago gave up on the red end of the spectrum. These fish, though, have altered their own retinas with a pigment they appear to obtain from their diet in order to see the red they make. The result is a searchlight that illuminates their surroundings while remaining, to almost every other animal present, completely dark. They can look without being seen looking. It is a quiet, private, self-contained arrangement and one of my favourite pieces of engineering anywhere in the natural world. Fact number 18. In the same spirit of not being seen, some deep-sea fish have evolved skin so black that it is difficult to describe. Ordinary black paint reflects perhaps 3 or 4% of the light that hits it. The skin of certain deep-sea fish, including some of the fangtooths and the black sea devils, reflects less than half of 1%. That puts it in the same class as the engineered ultra-black materials that laboratories are so proud of. The trick lies in the arrangement of pigment granules in the skin, packed at a size and spacing that catch stray photons and bounce them sideways into their neighbours until the light has nowhere left to go. When photographers try to shoot these fish, the animals come out as fish-shaped absences, a hole cut in the picture. In a world where the only light is the light other animals make, being unreflective is the same thing as being invisible. Fact number 19. The little organs that produce all this light are called photophores, and they are far more sophisticated than mere glowing spots. A well-developed photophore has a layer of light-producing cells at the back, a reflector behind them made of stacked crystalline plates to throw the light forward, a lens in front to focus the beam, and often a colour filter and an adjustable shutter of dark pigment to switch it on and off. In other words, it is a torch, complete with a mirror, a lens and a switch, grown from scratch in the skin of a fish. Some squid have photophores with irises. Some have photophores that can rotate. Certain lanternfish carry species-specific patterns of them along their flanks, arranged like the lit portholes of a passenger ferry, and it is thought that these patterns let them recognise their own kind in the dark. In the deep sea, a face is not much use. A constellation is better. Fact number 20. Not all light in the deep is for hiding or for hunting. Some of it is a cry for help. And one of the best examples belongs to a small, deep red jellyfish called the atolla. When something grabs an atolla, it does not fight and it cannot flee quickly. Instead, it begins to flash, and not randomly. It produces a spinning pinwheel of blue light that rotates around the rim of its bell, over and over, bright and rhythmic and visible for perhaps 100 meters in every direction. Researchers call it the burglar alarm. The logic is startling once you hear it. The jellyfish is not trying to frighten its attacker. It is advertising its attacker's position, in the hope of attracting something even bigger that will come and interrupt the meal. It is the deep sea equivalent of screaming in a quiet street. It works well enough that scientists have built an electronic imitation of it, a small ring of blue lights called the electronic jellyfish, and lowered it into the dark with a camera beside it, and the deep has come to see what the commotion was about. Half an hour into the descent now. Inside the Thessaly, Ines Marchetti has switched off the interior lights, because the sphere's little window shows more when the cabin is dark, and because it saves power, and because after 11 years she still likes to sit in the quiet and watch. The depth reading climbs steadily. 900 meters. 1,000. Outside the window there is no sun left at all, and yet the water is not empty. Small flecks are rising past the glass, or rather the submersible is falling past them, and they catch the faint glow of the instrument panel like dust in a shaft of afternoon light through a curtain. Ines calls it the snow. Everybody who has ever gone down calls it the snow. It falls all day and all night, in every ocean, in every season, in perfect silence, and it is the single most important thing happening in the deep sea. Fact number 21. Marine snow is the name given to the endless slow shower of organic particles that drifts down from the sunlit surface toward the abyss. It is made of everything that the upper ocean is finished with. Dead plankton, fragments of algae, the empty jelly houses that little creatures called larvaceans build to filter their food and then discard several times a day like used paper coffee filters. Fish scales, fecal pellets, which sounds unlovely but which are in fact tidy, dense, nutrient-rich parcels that sink beautifully. Dust blown off deserts, soot, grains of sand carried out by rivers, all of it clumps together in the water, glued by transparent sticky exudates from bacteria and algae into fluffy pale aggregates a few millimeters across, and down it goes. Under a submersible's lights it looks exactly like a snowstorm seen through a car windscreen at night, except that it never stops, and never settles, and never melts. It is falling right now, over every deep basin on Earth, and it has been falling for as long as there has been life in the sea. Fact number 22. Marine snow falls slowly, and the speed matters enormously. A single small flake might sink only 10 or 20 meters in a day, which means that if it began its journey at the surface over an abyssal plain, it would take a year or more to arrive, and would almost certainly be eaten on the way. Larger, denser aggregates fall much faster, perhaps 100 or 200 meters a day, and those are the ones that make it. The result is a kind of vertical sorting. The deep sea is fed not by everything that dies at the surface, but by the small fraction of it that manages to clump together well enough to fall fast enough. Only around 1 or 2% of the organic matter produced in the sunlit surface waters ever reaches the deep sea floor. The rest is intercepted, eaten, recycled, and eaten again on the way down. Every animal in the midnight zone is living on the crumbs of crumbs, which is precisely why the deep runs so slowly and so patiently. There is no feasting down here. There is only a very long, very thin, very reliable trickle. Fact number 23. Now and then, though, the deep receives a delivery on an entirely different scale, and the whole neighborhood is transformed. When a great whale dies, its body eventually sinks, and what lands on the abyssal plain is not a crumb, but a mountain of food, perhaps 30 or 40 tons of it, arriving all at once in a place that normally receives a few grams per square meter per year. Scientists call this a whale fall, and it is one of the most remarkable events in deep-sea ecology. Within hours, the first scavengers arrive, drawn from kilometers away by scent trailing on the slow bottom currents. Sleeper sharks, hagfish, swarms of pale amphipods, no bigger than a fingernail. They strip the soft tissue over months, sometimes a year or two. Then a second community moves in to work over the enriched sediment around the skeleton, worms and snails and crustaceans in their thousands. And finally, the bones themselves become a habitat that can last for decades. A single whale fall can support a small localized ecosystem for 50 years or more, which means that the death of one animal at the surface becomes half a century of life in the dark. Fact number 24. Among the creatures that arrive at a whale fall is one of the strangest and gentlest animals in the sea, a small worm in the genus Osedax, whose name means bone devourer. It has no mouth, it has no stomach, it has no gut of any kind. What it has instead is a set of root-like structures that it drills and dissolves into the whale's bone, and inside those roots live colonies of bacteria that break down the fats and proteins locked in the bone and share the results with their host. Above the bone, the worm puts out a plume of feathery red gills that waves gently in the current, so that a picked clean whale skeleton on the abyssal plain becomes, over time, a garden. Pale ribs and vertebrae, fuzzy with soft crimson flowers, swaying very slightly. The first of these worms was described only in the early 2000s, and dozens of species have been found since, in every ocean, wherever bones fall. Fact number 25. Whales are not the only large parcels the deep receives. Rivers in flood carry whole trees out to sea, and those trees eventually waterlog and sink, and where they land they too become an event. A single sunken log on the deep seafloor develops its own community of specialist animals, chief among them the wood-boring bivalves. Small pale clams that riddle the timber with tunnels and, like the boneworms, rely on symbiotic bacteria to digest cellulose they could never handle alone. As the clams work, they release nutrients into the sediment, and other creatures gather to take advantage. They're a species of deep-sea animal known only from sunken wood, found nowhere else on Earth, whose entire evolutionary strategy depends on a tree falling into a river on a continent they will never see, thousands of kilometers away and several kilometers up. Researchers study them by deliberately sinking bundles of timber and coming back a few years later to see who moved in. Fact number 26. The same is true of kelp and of sargassum, the floating brown seaweed that drifts in great golden rafts across parts of the Atlantic. When those rafts eventually break apart and sink, they carry surface productivity down into the dark in a single generous package. In some regions, particularly beneath rich coastal kelp forests, these falls are frequent enough that the deep community beneath is measurably better fed than the same depth 100 kilometers offshore. The deep sea, in other words, has weather after all. Not wind and rain, but a slow, irregular, patchy weather of arriving food, a steady drizzle of snow, an occasional shower of leaves and, very rarely and very wonderfully, a whale. Fact number 27. The most numerous large animals on the abyssal plain are sea cucumbers, and they are the deep's gardeners. In some regions they make up the overwhelming majority of the animal biomass visible on the seabed, and photographs of the abyssal floor often show them scattered across the pale ooze like plums on a bedsheet. They come in extraordinary shapes, some translucent and pink, some purple and lumpy, some with a fringe of tube feet like a hem of lace, some with a great sail on their back that lets them lift off the bottom and drift with the current when the mood takes them. What they all do, patiently, endlessly, is eat sediment. They vacuum up the top layer of ooze, extract whatever organic matter the marine snow has delivered, and pass the rest out behind them. In doing so, they turn over the surface of the abyssal plain, aerate it, and redistribute nutrients through it, exactly as earthworms do in a garden bed. Fact number 28. Because food is so scarce, the deep sea is dominated by animals that are extremely good at being patient. Metabolism slows down. Growth slows down. Reproduction slows down. Many deep-sea fish grow only a centimetre or two a year and may not breed until they are decades old. Deep-sea crustaceans can survive extraordinary fasts. A great many bottom-dwelling animals have adopted a lifestyle of doing almost nothing, very slowly, for a very long time, and it works. In the shallow, sunlit, competitive world above, speed is rewarded. In the deep, thrift is rewarded. There is an odd comfort in that. An entire third of the planet's living space runs on the principle that if you simply wait, quietly, without spending anything, something will eventually drift down to you. Fact number 29. All this sinking has a consequence far larger than the animals involved, and it is called the biological carbon pump. Every scrap of marine snow that reaches the deep and is buried in the sediment is carbon that has been taken out of the atmosphere by microscopic algae at the surface and locked away where it cannot return for centuries or millennia. This slow rain moves something in the order of several billion tons of carbon into the deep ocean each year. Without it, the atmosphere above you would hold dramatically more carbon dioxide than it does, and the world would be a considerably warmer place. The deep sea is not merely a large dark room. It is the planet's ballast, its long-term memory, and the quiet mechanism by which the surface world is kept livable, run entirely by creatures too small to see and driven by nothing more energetic than gravity. Fact number 30. And the sediment that all this snow eventually becomes is the slowest accumulating surface on Earth. On the deep abyssal plains, Far from any continent, the seafloor gains perhaps 1 millimetre of new sediment every 1,000 years. 1 millimetre. In some regions it is less, which means that if you could stand on the abyssal plain and press your thumb into the ooze, you would be pressing through 100,000 years of falling snow before you reached the layer that was settling when the last ice age ended. Everything that has ever happened in the ocean above has been recorded there, in order, undisturbed, in a book with pages thinner than paper. Sediment cores drilled from the deep are red like tree rings, and they hold the climate history of the world going back tens of millions of years, written in nothing but the patient accumulation of the dead. 2,400 metres now, and Ineas Marchetti has begun to slow the Thessaly's descent, feeding a little air into the variable ballast, listening to the small sounds a submersible makes when it is doing exactly what it should. Up on the Corvina, Tobias Lund has the sonar returns on a screen beside his headphones, and he can see the seafloor coming up to meet her as a soft yellow line, and he can see that the line is not flat here. It rises. It rises steeply, in fact, into a broken ridge of young volcanic rock, and somewhere along that ridge, if the coordinates are right, there is warm water leaking out of the planet. He tells her the range in a calm voice, and she says thank you in a calmer one, and the two of them go back to listening. Fact number 31. Until 1977, essentially every biologist on Earth believed the same simple thing, that all life ultimately depends on sunlight. Plants and algae capture it, everything else eats them or eats something that did, and the deep sea survives on the crumbs falling from that sunlit table. Then, in February of that year, a small American submersible called Alvin descended onto the Galapagos Rift, about 2.5 kilometers down, on a geology cruise. The scientists aboard were looking for warm water seeping out of the young seafloor. They were not looking for animals, and there were no biologists on the ship. What they found, clustered around shimmering plumes of warm water rising from cracks in freshback basalt, was a dense, thriving, impossible community, white clams the size of dinner plates, blind pale crabs, and great stands of tube worms taller than a person, tipped in blood red. There was more life packed into a few square meters of that rift than in 100 square kilometers of surrounding abyssal plain. The crew had no preservative aboard suitable for specimens, and the story goes that they emptied the ship's supply of vodka to bring samples home. It remains one of the great surprises in the history of science, and it was found by people who had gone looking for hot rocks. Fact number 32. The reason those animals could live there is a process called chemosynthesis, and it rearranged our understanding of what life requires. Seawater seeping down through cracks in the young volcanic crust is heated, stripped of oxygen, and loaded with dissolved minerals and hydrogen sulfide, the compound that gives rotten eggs their smell. When that hot chemically loaded water rises back out and meets cold, oxygen-rich seawater, there is energy available in the reaction between the two. Certain bacteria have learned to harvest that energy and use it to build sugars out of carbon dioxide, exactly as a leaf does, except that the power source is not a star 93 million miles away, but the chemistry of the planet itself. These bacteria are the grass of the vent fields. Everything else grazes on them, or farms them, or houses them inside its own body. It means that an entire complete ecosystem can exist with no connection whatsoever to the sun, which in turn means that life elsewhere, on a moon with a frozen crust and a warm ocean beneath it, is a far less outlandish idea than it was on the day before that dive. Fact number 33. The most dramatic vents are called black smokers, and they are among the few genuinely theatrical sights in the deep. Where the venting water is hottest and richest in dissolved metals, it emerges through a chimney of its own making, a rough, crusted spire of mineral precipitate that can grow to the height of a 4-story building. Out of the top comes a rolling black column that looks exactly like smoke from an old factory, but is in fact a cloud of tiny metal sulfide particles crystallizing instantly as the hot water hits the cold. The water leaving those chimneys has been measured at over 400 degrees Celsius. It does not boil, and it does not turn to steam, because the pressure at that depth is so immense that water simply cannot become a gas. It stays liquid, superheated, and then within centimetres of leaving the chimney it has cooled to a few degrees above freezing again. Life crowds right up to the edge of that gradient, arranging itself in bands along the temperature, each species occupying its own comfortable stripe in a rainbow you would need a thermometer to see. Fact number 34. Not all vents are hot and black. In the year 2000, an expedition working near the Mid-Atlantic Ridge came upon something entirely different and named it the Lost City. There, the venting is not driven by fresh magma, but by a slow chemical reaction between seawater and the rock of the Earth's mantle, a process called serpentinization, which produces gentle warmth, alkaline fluids, and hydrogen. The chimneys that grow there are not dark and crusted, but pale, delicate, carbonate towers, white as chalk, some of them 60 metres tall, fluted and pinnacled and looking for all the world like the spires of a drowned cathedral standing in a field of blue-black rock. The fluids come out at a mild temperature, perhaps 40 to 90 degrees, and the whole system may have been running continuously for 100,000 years. Many researchers consider it the closest thing we have found to the sort of place where life on Earth might first have started. Warm, alkaline, hydrogen-rich, sheltered, and in no hurry whatsoever. Fact number 35. The great red-tipped tube worms of the Pacific vents, Riftia, are perhaps the most famous inhabitants of these places, and their arrangement is astonishing. They grow in bunches like organ pipes, white leathery tubes up to 2 meters long, and from the open end of each tube a plume of feathery gill tissue extends, bright scarlet with hemoglobin, and withdraws instantly if disturbed. An adult Riftia has no mouth, it has no anus, it has no digestive tract at all. What it has, filling most of its body, is an organ called the trophosome, packed with billions of symbiotic bacteria. The worm's job is simply to be a very good delivery system. Its plume absorbs oxygen, carbon dioxide and hydrogen sulfide from the water and carries all three, in a specially adapted hemoglobin that can hold them at once without poisoning itself. Down to the bacteria. The bacteria do the chemistry and feed the worm from the inside. A larva hatches with a perfectly ordinary mouth and gut, acquires its bacteria from the surrounding water, and then dissolves its own digestive system, having no further use for it. They grow faster than almost any other deep-sea invertebrate known, going from settlement to 1.5 meters in a couple of years, because unlike almost everything else down there, they are never ever hungry. The Thessaly is over the vent field now, hanging a few meters above the rock, and the view through the little round window is the strangest garden Inez Marchetti has ever been asked to look at. Her lights pick out chimneys, dozens of them, some no taller than a milk bottle, some as tall as a house, and the water above them shimmers the way air shimmers over a road in summer. Everything is furred with life. She keeps the thrusters gentle, because a careless wash of propeller water can knock a 50-year-old chimney over, and because there is no particular hurry. The sonar altimeter murmurs. Up on the ship, Priya Anand has come into the control van with 2 mugs of tea and has forgotten to drink either of them, because the video feed is showing her something she did not know the world contained. Tobias Lund, who has seen this before, watches her face instead of the screen for a moment, and smiles, and says nothing. Fact number 36. Living on the walls of the hottest chimneys is an animal that holds one of the great heat records in the animal kingdom. It is called the Pompeii worm, and it builds a papery tube attached directly to the chimney wall, with its tail end down in water that has been measured at temperatures well above 80 degrees Celsius, while its head, poking out into the passing current, sits in water at around 20. That is a difference of 60 degrees across the length of a single animal, roughly the difference between a hot bath and a cold cellar, maintained permanently along a body the length of your finger. Its back is covered in a thick fleece of grey filamentous bacteria, so dense that the worm appears to be wearing a shaggy coat, and it is thought that this living blanket may act as insulation, or as a chemical buffer, or possibly as a packed lunch. Nobody is entirely certain, because bringing a Pompeii worm to the surface alive through several kilometers of cold water and a 1,000-fold drop in pressure is close to impossible. Almost everything we know about it we know from photographs, from careful measurements taken by robotic arm, and from specimens that arrive dead. It is one of many creatures down there that we have seen clearly and understood only partly. Fact number 37. In 2005, on a vent field south of Easter Island, researchers pulled up a crab that made everybody laugh out loud. It was pale, almost white, blind, about the size of a hand, and its claws and forelimbs were covered in long, silky blonde bristles, so that it looked as though it were wearing a fur coat several sizes too large. They called it the Yeti crab. It took a few more years to work out what the fur was for, and the answer is charming. It is a farm. The bristles are colonized by dense mats of chemosynthetic bacteria, and the crab feeds on them, combing them off with specially adapted mouthparts. Later relatives found near Costa Rica and in the Southern Ocean were observed doing something even better. To keep their crop healthy, the bacteria need a steady supply of both the chemicals from the vent and the oxygen from the surrounding seawater. So the crabs position themselves in the mixing zone and wave their arms rhythmically back and forth through the shimmer, stirring the water over their bristles. Researchers watching hours of footage described it, entirely accurately, as dancing. Whole crowds of them, packed shoulder to shoulder on warm rock in absolute darkness, slowly waving. Fact number 38. On vents in the Indian Ocean lives a snail that has done something no other animal on Earth is known to do. It has made itself a suit of iron. The scaly-foot snail has a broad muscular foot armoured with hundreds of overlapping plates, and both those plates and the outer layer of its shell are mineralized with iron sulfides drawn from the vent fluid it lives in. The shell has 3 layers: an iron-plated outer coat, a soft, squashy middle layer that absorbs and dissipates impacts, and a hard inner layer, which is essentially the design principle behind good body armor and was arrived at here without any design at all. The snail is magnetic. If you bring a magnet near a preserved specimen, it responds. Like the tube worms, it has a reduced digestive system and depends on symbiotic bacteria housed in an enormously enlarged gland in its throat. It is known from only 3 vent fields in the whole world, each one a tiny island of warmth on an otherwise cold and featureless plain, and in 2019 it became the first species to be listed as endangered, specifically because of the threat of deep-sea mining. Fact number 39. Vents are not the only places where the planet feeds the deep. In many parts of the world, particularly along continental margins, methane and hydrogen sulfides seep gently out of the sediment without any heat at all, and these are called cold seeps. They are far less dramatic than a black smoker and considerably longer lived. A vent field, tied to a particular pulse of volcanic activity, may run for a few decades and then fall silent, forcing everything living on it to find a new home. A cold seep can flow steadily for thousands of years. Around them grow great pale beds of mussels and clams, thickets of tube worms of a different and much slower kind, and mats of bacteria in strange white and orange and lilac patterns that look from above like lichen on a stone wall. Some of those seep tube worms are believed to be among the longest-lived animals known, growing so slowly that individuals of 200, 300, perhaps 500 years old are considered unremarkable. They were already there when the first sailing ships passed overhead. Fact number 40. Where the seeping fluid is exceptionally salty, the deep sea does something that sounds like a mistake in the telling. It forms lakes. Brine pools are pockets of water so heavily loaded with dissolved salt, often from ancient buried salt deposits, that they are significantly denser than ordinary seawater and simply refuse to mix with it. They collect in hollows on the seafloor and sit there, sometimes for millennia, forming pools with a genuine visible rippling surface and a definite shoreline. Submersibles have filmed their own reflection in one. The pools have waves. Push a robot arm into one and the surface parts and closes behind it, and the disturbed brine sloshes and settles like syrup. Around the rim, where brine meets seawater, there is often a dense ring of mussels living on the chemistry, so that the lake appears to have a beach of shellfish. It is a lake at the bottom of the sea with a shore and a surface, and its own small weather of slow currents, and nobody who sees one for the first time quite believes what they are looking at. Inns Marchetti has left the vent field behind and is drifting out over open water again, holding depth, letting the current carry the Thessaly slowly north. This is the part of a dive she likes best and never puts in the log, because there is nothing to log. There is only a woman in a metal ball 3 kilometers down, with the lights off, watching. Every so often something passes the window, a pale shrimp hanging vertically, a ribbon of siphonophore longer than the submersible going by like a train, a single flash of blue far off in the dark, from something that has decided to say something to somebody. She has learned to sit still through all of it. The animals that live out here in the open midnight zone are, on the whole, delicate, slow, unhurried, and entirely uninterested in her. They have no reason to fear a machine, because nothing in 300 million years has taught them to. Fact number 41. The giant squid was, for most of recorded history, a story. Sailors described enormous arms rising from the sea, and naturalists filed the accounts alongside mermaids and sea serpents, and for a long time the only real evidence was the occasional battered carcass washed up on a beach or found floating, and the circular scars, the size of saucers, that show up on the skin of sperm whales. The animal itself was never seen alive by anybody, at any depth ever. Then in 2004, a Japanese team lowered a baited line with a camera on it into deep water south of Tokyo and captured the first photographs of a living giant squid in its own world. In 2012, a crude submersible filmed one properly. A shining silver and copper animal that came drifting into the lights, examined the vehicle, and moved on. It was worth the wait. A giant squid can reach 12 or 13 meters from the tip of its tail to the ends of its 2 long feeding tentacles, and its eye is the largest eye of any animal that has ever lived, up to 27 centimeters across, roughly the size of a dinner plate. Such an eye is not for reading fine print, it is for detecting, at great range in almost no light, the faint disturbance glow of plankton stirred up by something very large approaching. Fact number 42. There is a squid heavier still, and it lives in the freezing water around Antarctica. The colossal squid is shorter in the arms than its famous cousin, but far more solidly built, and it is the heaviest invertebrate on Earth, with the largest confirmed specimen weighing close to half a ton. Where the giant squid has suckers lined with small teeth, the colossal squid has, on the ends of its 2 clubbed tentacles, rotating hooks mounted on swivels, which is an unnerving detail told plainly, and a rather elegant one told properly. Swiveling hooks grip a struggling animal without tearing, distributing load in whatever direction the prey happens to pull. Almost everything we know about the species comes from the stomachs of sperm whales, from a handful of specimens brought up accidentally by fishing vessels, and from a very small number of encounters at depth. In 2025, a remotely operated vehicle working in the Southern Ocean filmed a juvenile colossal squid alive in the deep for the first time. A small transparent creature about 30 centimeters long, entirely see-through, hanging in the water like a piece of blown glass. The largest invertebrate on the planet begins as something you could hold in a cupped hand and read a newspaper through. Fact number 43. The animals that hunt those squid are not deep-sea residents at all. They are mammals who breathe air, and their commute is one of the most extraordinary athletic feats in nature. A sperm whale routinely dives to 600 or 800 meters, frequently passes 1,000, and has been recorded well beyond 2,000. A typical foraging dive lasts around 45 minutes to an hour. On the way down, the whale collapses its own lungs deliberately, letting the air be squeezed into rigid airways where the nitrogen cannot dissolve into its blood, and it shuts down circulation to everything not immediately required, storing oxygen instead in enormously enriched muscle tissue, which is why whale meat is so dark. Its heart may slow to a few beats a minute. And then it hunts in complete darkness, entirely by sound, clicking and listening, building a picture of the water around it out of echoes. Sperm whales sleep too, and they do it in a way that people who have filmed it never quite get over. They hang motionless and vertical, nose up in loose groups, drifting together in the blue like a stand of enormous grey trees. Fact number 44. The record for the deepest and longest dive by any mammal belongs, as far as we know, to a far less famous animal, the Cuvier's beaked whale. These are shy, seldom-seen creatures, grey-brown and scarred, with a short beak and a habit of avoiding boats. In 2014, a tagged individual off the coast of California was recorded at 2,992 meters. In 2020, off North Carolina, another was recorded staying underwater for 3 hours and 42 minutes on a single breath. 3 hours and 42 minutes. The physiologists who published it were careful to note that this was almost certainly an unusual dive, perhaps a response to disturbance, but the animal did it and surfaced and swam away. To hold your breath for that long, you must not merely store oxygen well. You must be able to run large portions of your body without it for a long time, and then repay the debt calmly afterwards. It is the deep sea equivalent of walking out of your front door and returning 3.5 hours later, having been to the bottom of a canyon and back, without hurrying. Fact number 45. Down on the seafloor, meanwhile, there is a creature that has taken the opposite approach to life entirely, and it is one of the great gentle oddities of the deep. The giant isopod is a crustacean, closely related to the woodlice that live under damp bricks in a garden, except that it can grow to 50 centimeters long and weigh nearly 2 kilograms. It has 14 legs, a segmented armoured back the colour of pale butter, and 2 large compound eyes fixed permanently open. It walks slowly across the abyssal plain, or lies still on it, waiting for something to fall. Because that something may not fall for years, the giant isopod has become one of the champion fasters of the animal world. Individuals kept in aquariums have refused all food for extraordinary lengths of time, and remained in perfect health. One famous specimen in a Japanese aquarium ate nothing at all for over 5 years, and appeared entirely content throughout. And this behaviour is not a sickness or a protest. It is simply what the animal is built for. When food does arrive, an isopod will gorge until it can barely move, filling itself to capacity, and then settle down and wait, patiently, for however long the deep decides to take. Let us pause here for a moment, halfway through the animals, and say something about size, because the deep sea plays games with it, and it is worth knowing the rules before we go on. Almost everything you have seen in a photograph of the deep has been photographed close up, against black water, with no fish market crate or human hand beside it to give a sense of scale. The result is that we all carry around a mental gallery of deep sea creatures that is wildly, comically out of proportion. The famous fanged anglerfish that appears in every documentary is, in life, about the length of a teaspoon. The gulper eel with its terrible balloon of a mouth would fit in a shoebox with room to spare. The viperfish, that great toothy poster child of the abyss, is usually under 30 centimetres, which is to say it would look small on a dinner plate. Meanwhile, the genuinely enormous animals of the deep, the squids and the sleeper sharks and the beaked whales, are almost never seen at all, because they are fast enough, or shy enough, or simply lucky enough to avoid every camera we have ever lowered. So the deep sea's public image is upside down. We know the little ones intimately, magnified and lit like film stars, and the big ones are rumours. And there is a second thing that photographs cannot show, which is texture. Nearly everything down there is soft. In an environment where food is scarce, and there is nothing to hide behind, and no hard surface to be smashed against, muscle is expensive and armour is usually pointless, and so the deep has filled itself with animals made of jelly, of loose watery flesh, of transparent membrane and thin skin. Jellyfish, comb jellies, siphonophores, salps, larvaceans, soft-bodied squid, snailfish like wet tissue, sea cucumbers that fall apart when touched. Most of the biomass of the open midnight zone is, in a word, squishy. This is why the deep was misunderstood for so long. For a century, everything we knew came from nets, and nets destroy soft animals utterly. What arrives on deck after a haul from 3,000 meters is a bucket of transparent mush with a few hard-bodied crustaceans and fish in it. So for decades, our picture of the deep was of a place inhabited chiefly by bony fish and shrimp. It was only when submersibles and remote vehicles began drifting quietly through the water and filming things where they lived that the truth emerged. The deep ocean is overwhelmingly a world of gelatinous animals, drifting, pulsing, trailing, glowing, and so fragile that we spent 100 years turning them into soup before we ever saw one whole. Some of them are enormous, in their soft way. A single siphonophore, which is not one animal but a colony of specialized individuals strung together in a chain, can extend more than 40 meters, longer than a blue whale, while being no thicker than a broom handle and weighing almost nothing at all. In 2020, off the coast of Western Australia, an expedition filmed one arranged in a slowly rotating spiral, hanging in the water like a galaxy made of glass. Nobody has ever weighed it, and nobody ever will, because you could not bring it up without it coming apart in your hands. Fact number 46. On the slopes off the coast of Japan lives an animal that looks like a drawing from a children's book of impossible things. The Japanese spider crab has a body no bigger than a football, and legs that can span nearly 4 meters from claw tip to claw tip, making it the largest arthropod on Earth by leg span. It moves with enormous deliberation across the muddy slopes at a few 100 meters depth, picking through the sediment, and it is, despite its scale, an entirely peaceable animal, a scavenger and a gentle forager. It is also thought to be very long-lived, with estimates running to a century or more, and its shell is often crusted with sponges and anemones that it appears to encourage, a slow accumulation of passengers gathered over decades. Watching one walk is a lesson in unhurriedness. Each leg lifts, hesitates, considers, and sets down. There is no urgency anywhere in the animal. It has been doing this since before anyone you know was born, and it intends to keep doing it. Fact number 47. The longest bony fish in the world is a creature that has probably done more than any other to invent the sea serpent. The oarfish is a ribbon of silver flattened side to side that can reach 8 meters and possibly more, with a crest of scarlet fin rays rising from its head like a plume and a single long red dorsal fin running the entire length of its back. It has no scales, no teeth to speak of, and it feeds on tiny drifting animals it strains from the water. Its usual home is the twilight zone, several 100 meters down, and it swims in a way nobody expected until it was finally filmed, not horizontally like a normal fish, but vertically, head up, hanging in the water like a column of tinsel, propelling itself by rippling that long red fin while the body stays almost still. When one washes ashore, which happens rarely, it makes the local news, because there is nothing in the ordinary run of things that prepares a person for a 5-meter silver ribbon lying on a beach with a red crown on its head. Fact number 48. In the cold water of the North Atlantic and the Arctic swims what may be the longest-lived vertebrate on Earth. The Greenland shark is a large, heavy, slow-moving animal, grey-brown and blunt, that cruises at a pace of well under 1 kilometre an hour, which is slower than a person strolling. In 2016, researchers used radiocarbon dating of the proteins in the lenses of their eyes, which form before birth and never change afterwards, to estimate the ages of a series of specimens. The results suggested lifespans of at least 270 years, with the largest individual estimated, with wide uncertainty, at something near 400. They may not reproduce until they are around 150 years old. Sit with that for a moment as you lie there in the dark. There are sharks alive right now, moving very slowly through cold water off Greenland that were already swimming when the first steam engines were being built. They are nearly blind, most of them, and they do not seem to mind. Fact number 49. The deepest living octopus we know of is also the sweetest to look at, and it is properly called Grimpoteuthis, though nobody calls it that. Everybody calls it the Dumbo octopus, because of the two soft fins that stick out from the top of its mantle, one on each side, and flap gently as it swims, exactly like a pair of ears. It lives on and just above the seafloor, at depths from 3,000 meters down to 7,000 and beyond. Deeper than any other octopus known, and it is small, usually about 20 or 30 centimeters, and gelatinous, and comes in shades of pink and cream and pale mauve. It does not have an ink sac, because there is nothing to hide behind ink from down there. It swims by flapping those fins and by slowly opening and closing the webbing between its arms, so that it moves through the dark by turning into a little umbrella and back again. It hovers over the sediment, drops onto small prey, and swallows things whole. Of all the animals in the deep sea, it is the one most likely to make a room full of adults make the same soft noise at once. Fact number 50. And now let me clear the name of a creature that has been badly served by its own scientific name for over a century. The vampire squid is called Vampiroteuthis infernalis, which translates with wonderful 19th century relish as the vampire squid from hell. It is a small animal, about 30 centimeters long, deep red or black, with large blue eyes and webbing between its arms that it can pull up over itself like a cloak when it is startled, turning inside out into a spiky-looking ball. It lives in the oxygen minimum zone, 600 to 900 meters down, where there is so little dissolved oxygen that almost nothing else can survive, which it manages by having the slowest metabolism of any deep-sea cephalopod measured and by barely moving. And what does this creature from hell eat? Marine snow. It is a detritivore. It puts out two long, thin, sticky filaments into the water, far longer than its own body, and lets them drift, collecting falling particles, and then draws them in and combs the material off with its arms, mixes it with mucus, and eats the resulting small grey parcel. It is not a hunter of anything. It is a gentle, slow, red-cloaked, blue-eyed animal that lives in still water and eats dust, and it has spent 120 years being called a demon by people who never watched it work. Somewhere above the Thessaly, in the black water between 2,000 and 1,000 meters, the evening traffic is moving. Tobias Lund can see it on his echo sounder as a broad, soft band, thicker than the seafloor return and much fainter, rising slowly up the screen. It has been doing this every evening of his life, and every evening of everyone's life, and he has watched it hundreds of times and still finds it moving. Priya Anand asks him what it is, and he says more or less that it is dinner going upstairs. We will come to that in a little while. For now, let us stay down in the quiet and meet a few of the residents, because the Midnight Zone has a reputation it does not entirely deserve, and most of the animals in it are far smaller, far softer and far more thoughtful than the posters suggest. Fact number 51. The deep-sea anglerfishes are the great emblem of the deep, and almost everything most people picture about them is out of scale. A typical female anglerfish is not the size of a car. She is usually somewhere between 5 and 20 centimeters long, which is to say she would sit comfortably in the palm of your hand, and the very largest species reach perhaps a meter. Her famous fishing rod is a modified spine of the dorsal fin, grown forward over the head and tipped with a small fleshy lure called an esker, which glows. She does not chase anything. Chasing costs energy, and energy in the Midnight Zone is the scarcest currency there is. Instead, she hangs almost motionless in the water, sometimes upside down, sometimes tilted, and she waves the little light very slowly, and she waits. Footage taken by submersibles shows this beautifully, an animal doing essentially nothing, for hours, with a small blue star bobbing gently in front of her face. Her body is soft, watery and low in muscle, because she does not need muscle. In a world where meals are rare, the winning strategy is not strength. It is stillness, and a good light, and the patience to keep it burning. Fact number 52. The light on the end of that rod is not hers. Inside the esker is a chamber, open to the sea by a tiny pore, and inside that chamber live colonies of bioluminescent bacteria that the anglerfish acquires from the surrounding water rather than inheriting from her mother. The bacteria glow. She provides them with shelter and nutrients, and controls the light by widening or narrowing the blood vessels around the chamber, dimming and brightening the lure much as you might turn down a lamp. Genetic work on these bacteria has revealed something rather touching. Their genomes are in the process of shrinking. Because they live in such a sheltered, reliable environment, and because they no longer need most of the machinery required to survive independently in open seawater, they have been quietly discarding it, gene by gene, over evolutionary time. Two organisms, one very small and one only slightly less small, have come to an arrangement in the dark, and both are becoming less able to live without the other with every passing million years. Fact number 53. In the Twilight Zone lives a small fish with a design so improbable that for decades scientists drew it wrongly, because every specimen they had was damaged. The barrel-eye fish is about 15 centimeters long, dark-bodied, with a broad, flat, transparent shield covering the whole top of its head, like a windscreen. Inside that transparent dome sit two large tubular eyes, brilliant emerald green, pointing straight upward. It hangs motionless in the water, looking up through its own forehead, scanning the faint blue glow above for the silhouettes of small animals passing overhead. The two dark spots on the front of its face, which look like eyes and which everybody assumes are eyes, are its nostrils. The transparent dome is so delicate that it is destroyed by the pressure change of being hauled up in a net, which is why nobody knew it existed until a submersible photographed a living one in 2004. And the eyes, it turns out, can rotate forward inside the dome, so that when the fish tips up to take something, it can watch its own mouth arrive. Fact number 54. The gulper eel, sometimes called the pelican eel, is a long dark ribbon of an animal with a whip-thin tail and a mouth that is essentially the entire front third of its body. The jaws are loosely hinged and the skin between them is enormously elastic, so that the whole head can balloon open into a great black pouch far wider than the eel itself. When a remotely operated vehicle filmed one in 2018 off the Hawaiian Islands, the footage went around the world, because the animal inflated to a shape resembling a wet balloon, held it for several seconds, and then deflated, quite calmly, back into a thin black ribbon and swam off with a faintly embarrassed dignity. The eyes are tiny. The teeth are tiny. The tail ends in a small glowing organ that the eel is thought to wave in front of itself. Almost nothing about it is built for strength, and nearly all of it is built for the possibility that one day something surprisingly large might drift within reach, and it would be a great shame to be unable to accommodate it. Fact number 55. Down on the abyssal plain, walking about in herds, are the sea pigs. They are sea cucumbers of the genus Scotoplanes, 5 to 15 centimeters long, pale pink and faintly translucent, plump as small marshmallows, and they stand on 5 to 7 pairs of enlarged tube feet that work exactly like stubby legs. Along their backs are further tube feet, elongated and held upright, which are thought to be sensory. What makes them such good company is that they travel in groups, sometimes hundreds strong, all facing the same direction, all moving at the same slow pace across the ooze, following the scent of something organic that has landed somewhere ahead of them. Photographs taken by seafloor landers show them arranged like a herd of pale grazing animals on an enormous flat plain, which is precisely what they are. Small juvenile king crabs are known to hide underneath them for protection. On an abyssal plain, where cover of any kind is unimaginable, a passing sea pig is the only roof for 1,000 kilometers, and the crabs take it. Take a slow breath in through the nose, if you are still awake enough to notice the instruction, and let it out through the mouth without hurrying it. Let your hands go loose. There is nothing coming. Nothing in the second half of this list is going to be any louder than the first. I want to say something about colour before we go on, because it is one of the small, gentle surprises of the deep, and it explains a great many photographs. a very large proportion of the animals living in the midnight zone are red. Deep red, crimson, brick, plum, scarlet, shrimp are red. Many jellyfish are red. Octopuses down there are often a rich rusty orange. Squid come in shades of maroon. If you sorted the residents of the deep ocean by colour, red would win by a wide margin, which seems at first like the worst possible decision. Red is the loudest colour we know. It is the colour of warning signs and fire engines and fresh paint. Except that down there, it is not a colour at all. Remember that red light vanishes within the first 15 metres of seawater, and that below 1,000 metres there is no sunlight of any wavelength whatsoever. The only light in the midnight zone is the blue light that animals make. And a red object, by definition, absorbs blue light and reflects red. So a bright scarlet shrimp, lit by the blue glow of a passing jellyfish, reflects essentially nothing back. It is not red down there. It is black. It is a hole. Being crimson in the deep sea is the most effective camouflage available, and it costs the animal nothing, and it happens to make every photograph taken with a white submersible lamp look like a jewellery advertisement. The same logic runs the other way for the transparent animals, and there are a great many of those too. Comb jellies, salps, larvaceans, glass squid, the young of almost everything. If you cannot absorb the light, let it pass straight through you. Some of these creatures are so completely transparent that the only part of them visible in a photograph is the dark pigment spot of an eye and a faint shimmer where the light bends, and a few have gone further still, evolving a reflective coating over the eye or twisting their gut so that the contents are hidden edge on. There is an animal in the deep that is invisible except for its own dinner. And then there is the third strategy, which we have already met. Be so black that you are less a shape than an absence. Red, transparent, or ultra-black. 3 answers to the same question, arrived at over and over by unrelated creatures across hundreds of millions of years, all of them meaning the same thing, which is simply, do not let anybody see me, because in a place this large and this empty, being noticed is the only thing that ever goes wrong. Settle back down now. Let your breathing go where it wants. We are going to look at some sponges, and some corals, and some very old and very patient things. Fact number 56. Some of the loveliest architecture in the deep sea is built out of glass. Glass sponges grow a skeleton of silica, the same material as window panes and sand, spun into fine needles called spicules and fused together into a rigid lattice. The most famous of them is the Venus flower basket, a hollow tube about 20 to 30 centimetres long, delicately curved, woven in a pattern of squares and diagonals so regular that engineers have studied it as a model for lightweight structures. It stands anchored in the sediment by a tuft of glass fibres, filtering food from the passing current, and it can live for a very long time. Inside many of these baskets you will find a pair of small shrimp, one male and one female. They enter as larvae when they are tiny enough to slip through the lattice, and then they grow, and then they cannot get out. They live their entire adult lives inside the sponge, cleaning it, feeding on what the current brings, and their own offspring drift out through the mesh to find baskets of their own. In Japan, the dried skeleton, with its lifelong pair sealed inside, has traditionally been given as a wedding present, which is either extremely romantic or a firm piece of advice, depending on your temperament. Fact number 57. The glass fibres in these sponges are not merely structural, they conduct light. Researchers testing them found that the natural spicules transmit light along their length with an efficiency comparable to commercial optical fibre, and in some respects better, because they are grown at the temperature of cold seawater rather than drawn from a furnace, which leaves them flexible enough to tie in a loose knot without shattering. Nobody is completely sure what, if anything, the sponge does with this. Perhaps it is a side effect of building good glass. Perhaps it distributes the faint bioluminescence of symbiotic organisms into the sponge's tissues. but it means that in the dark at 2,000 meters, there are animals quietly manufacturing fiber optics out of cold water and dissolved silica, without heat, without energy to spare, and doing it better than we manage in a factory. Fact number 58. On the abyssal floor there are single cells the size of your fist. Xenophyrophores are enormous single-celled organisms, giants among protists, and some species reach 20 centimeters across. They are not colonies. Each one is a single cell with many nuclei, which builds itself a delicate structure out of sediment grains, sponge spicules and other debris glued together with its own secretions, forming shapes like flattened rosettes, fans, honeycombs and crumpled paper bags. They are extremely fragile and almost impossible to collect intact, so they are studied mostly in photographs. In some parts of the deep Pacific they carpet the seafloor in remarkable densities, thousands per 100 square meters, and they provide shelter and nursery habitat for a whole community of tiny animals that live in and around their structures. A single cell, doing masonry, providing housing. In 2018, one was found in the Mariana Trench at more than 10,000 meters, which makes them among the deepest living organisms of any size known. Fact number 59. There are corals in the deep sea, and they are older than almost anything alive on land. Cold water corals need no sunlight and no symbiotic algae. They feed by catching particles from the current, which means they can grow at depths of hundreds or thousands of meters. On seamounts and canyon walls and continental slopes, in water just a few degrees above freezing. Their growth is correspondingly slow, in some species a fraction of a millimeter per year. Radiocarbon dating of black corals from off Hawaii has produced ages exceeding 4,000 years for individual colonies, and gold corals older still. A branching structure the size of a small tree standing on a rock 2 kilometers down may have been growing continuously since the pyramids were new. Around them gather fish, brittle stars, crinoids, shrimp and sponges, so that a cold water coral garden becomes one of the richest places in the deep, an oasis assembled 1 millimeter at a time over 4 millennia. Fact number 60. Deep sea reefs are not small features. Off the coast of Norway and along the edges of the Atlantic from Ireland to West Africa, there are reef structures built by a single stony coral, Desmophyllum petusum, that run for tens of kilometers and stand as much as 30 meters tall, all in water hundreds of meters deep and permanently dark. One reef complex off Norway is thought to be roughly 40 kilometers long. In 2024, mapping work along the southeastern United States revealed a nearly continuous cold water coral province stretching for hundreds of kilometers along the Blake Plateau, an area of ancient reef about the size of a small country, sitting in cold black water off one of the most heavily surveyed coastlines on Earth, essentially unnoticed until somebody finally ran the survey lines. That is the deep sea in a single example, not far away, not exotic, not hidden by anything, except the simple fact that light does not go there, and we very rarely do. Let us go back up to that soft band on the echo sounder, because it is the largest thing that happens on this planet every single day, and hardly anybody has heard of it. Tobias Lund has been watching it climb his screen since sunset. It is a broad, fuzzy, luminous layer a few hundred meters thick, and it has lifted from around 600 meters to around 200 over the course of the evening, and shortly before dawn it will sink back down again exactly as it rose. There is no wind involved, and no current. Every particle of that band is an animal, deciding, and there are a great many of them. Priya Anand leans on the back of his chair with her cold tea and asks how many. He shrugs, in the way of a man who has read the papers and does not want to overstate. Billions, he says. Possibly trillions. Every night. Everywhere. Fact number 61. During the Second World War, naval sonar operators began reporting a serious and puzzling problem. The seafloor was in the wrong place. Their instruments were returning a strong echo from a depth of a few hundred meters in water, known to be several kilometers deep, and worse, the false bottom moved. It rose toward the surface at dusk and sank again at dawn. Some feared it was an enemy trick. Some assumed the equipment was faulty. The truth worked out over the following years. Was far stranger and more wonderful. The echo was coming from the gas-filled swim bladders of countless small fish, and from the bodies of shrimp and squid and jellyfish layered so densely through the twilight zone that collectively they reflected sound like a solid surface. They named it the Deep Scattering Layer, and it exists in every ocean basin in the world. It is not a curiosity at the edge of the data. It is one of the loudest features in the sea. Fact number 62. The reason the layer moves is the largest migration of living things anywhere on Earth, and it happens twice a day, every day, without exception. It is called diel vertical migration. As the sun goes down, an immense population of small animals, most of them lanternfish and bristlemouths and krill and shrimp and squid, rises hundreds of meters from the safety of the dark and spends the night feeding in the richer, warmer surface waters. Before dawn, they sink back into the twilight, where they cannot be seen from above. They do it to eat without being eaten. The total biomass involved is measured in billions of tons, and the animals travel in some cases 500 or 600 meters in each direction, which for a creature the length of a finger is a commute of extraordinary proportions undertaken nightly for a whole lifetime. It is also quietly one of the most important carbon transport systems on the planet, because those animals feed at the surface and then descend and breathe out and excrete at depth, carrying carbon downward on a conveyor of living bodies. Fact number 63. The single most abundant vertebrate animal on the face of the earth lives in this layer, and almost nobody could name it. It is a bristlemouth, a small dark fish of the genus Cyclothone, rarely more than 5 or 6 centimeters long, with a mouth that seems too large for its face and a row of little photophores along its belly. Estimates of their total number run into the hundreds of trillions, and some researchers have suggested quadrillions. There are more of them than there are of every other kind of fish put together by a very wide margin, and more of them than there are birds, mammals, reptiles and amphibians combined by many orders of magnitude. They are not rare, not endangered, not hidden. They are simply small, and they live between 200 and 2,000 meters, and no one has any commercial reason to look at them. The most successful vertebrate on the planet is a fish you have never seen a photograph of, going quietly about its business in the dark in unimaginable numbers. Tonight, fact number 64. Sound behaves in the deep in a way that has no equivalent on land, and it produces one of the ocean's great secret structures. The speed of sound in seawater depends on temperature and pressure. Near the surface, water is warm and sound travels fast. Going down, the water cools and sound slows. Below a certain depth, the temperature stops falling, but the pressure keeps rising, and so sound speeds up again. Between the two, at roughly 1,000 meters in temperate latitudes, there is a layer of minimum sound speed, and sound waves entering that layer are gently bent back into it from above and below, over and over, so that they cannot escape. They are trapped and travel horizontally with almost no loss. This is the deep sound channel, sometimes called the SOFAR channel, and it means a modest noise made in the right place can be heard on the far side of an ocean basin. It was used during the Cold War to track submarines, and it was used, more happily, to detect the position of downed pilots by dropping small charges into it. Fact number 65. Whales appear to have found this channel long before we did. The low-frequency calls of fin whales and blue whales at around 20 Hz sit near the very bottom edge of human hearing and are produced at extraordinary volume, and they are the perfect frequency to travel through the deep sound channel with minimal absorption. How far they actually carry is genuinely debated, and honest researchers give ranges rather than headlines, certainly tens of kilometers in ordinary conditions, plausibly hundreds under good conditions, and, before the world's oceans filled with ship engines, quite possibly across an entire ocean basin. Ambient noise from commercial shipping has risen substantially over the past century in exactly the frequency band the great whales use, which has narrowed the range at which they can hear each other. There is something quietly moving in the thought that the largest animals ever to exist may once have been able to speak, from one continent to another, through a corridor of water they never had to see. Up in the acoustics cabin, Tobias Lund has a habit he has never mentioned to anybody. When the ship is quiet and the watch is long, he turns the hydrophone feed up in his headphones and simply listens to nothing in particular for a while, the way another person might sit at a window and watch rain. What he hears is not silence. It is a wide, soft, textured hush, like a very large hall with the doors open, and out of it come small events. A tick, a distant rumble that might be a ship 40 kilometers away or might be the seafloor settling. A long descending note from something enormous, so low that he feels it in his sternum before he identifies it in his ears. On a good night, a sequence of clicks, evenly spaced, unhurried, methodical, walking slowly across the stereo field from left to right over the course of 10 minutes, which is a sperm whale hunting somewhere below and passing by, entirely unaware that anybody is listening. He has never told anyone that he sometimes says goodnight to it. Priya Anand asks him once whether it ever gets boring, sitting in a small room in the dark listening to water, and he thinks about it properly before answering, because it is a fair question, and he has asked it of himself. He says that the sea is the only thing he has ever found that is genuinely inexhaustible. Not in the sense of being endlessly exciting, because it is mostly not exciting at all. In the sense that it never runs out. There is always another layer under the one you are attending to. If you listen to the loud things, you hear ships and whales. If you learn to hear past them, you find the shrimp and the ice and the rain. If you learn to hear past those, you find the hum of the planet itself, a note so low and so constant that it took physicists decades to agree it was real. And underneath even that, presumably, there is something else, and he will not live long enough to find out what. This, more than any single fact, is what people mean when they say the deep sea gets into you. It is not the monsters, because there are none. It is not the danger, because for a careful crew there is very little. It is the scale, and the patience, and the sense that whatever you learn tonight is a small correction to a very large ignorance, and that this is fine, and that it will still be true tomorrow. Down below, the Thessaly is holding at 3,200 meters in water that has not been warm since before the Roman Empire, and a woman inside it is watching a shrimp go past her window, and neither of them is in any hurry at all. Let us stay in the dark a little longer, and talk about how you find your way in a place where nobody can see. Fact number 66. In water where seeing is barely an option, feeling becomes the primary sense, and deep-sea fish are exquisitely equipped for it. Running along the flank of almost every fish is a lateral line, a canal just beneath the skin, containing rows of tiny hair cell sensors that detect minute changes in water pressure and movement. In shallow, busy, well-lit water it is a useful supplement to vision. In the deep it becomes something closer to a whole-body ear. Many deep-sea species have taken it much further than their surface relatives, with the lateral line canals enlarged, opened out into wide grooves, or extended onto long trailing filaments that stand out from the body like whiskers, sampling the water at a distance. Some deep-sea fish are covered in these sensors from snout to tail. What they perceive is not a picture, but a field. The soft push of something swimming past, the direction it went, the size of the disturbance it left behind. A creature can pass a meter away in complete blackness and be felt as clearly as you would feel a person walk behind your chair. Fact number 67. Smell in the deep is a slow, long-range, patient sense, and the speed at which it works has surprised everybody who has tested it. Drop a baited camera trap onto an abyssal plane thousands of meters down, in a place where the seafloor photographs show almost nothing living at all, and come back to the recording afterwards. Within minutes, the first amphipods arrive. These are small, pale, scavenging crustaceans, shrimp-like, usually a centimetre or two long, and they come in clouds. Within an hour there may be thousands of them, boiling over the bait. Within a few hours, the larger scavengers arrive: grenadier fish with tapering tails, cusk eels, sleeper sharks in some regions, hagfish in others. And then, when the bait is gone, over the following day, they all disperse back into the dark and the seafloor looks empty again. That is the truth of the abyss. It is not deserted, it is dispersed, and it is listening with its nose, and it can assemble a crowd out of apparently nothing whenever the sea provides a reason. Fact number 68. Down in the trenches at the very bottom of the Hadal Zone, the dominant animals are those same amphipods, and some of them grow to a size that seems like a misprint. Most deep-sea amphipods are the size of a grain of rice. In the Hadal trenches there are species reaching 28 or 30 centimetres, the length of a forearm, pale and translucent, with elegant fringed legs. Nobody is entirely sure why they get so big down there, though the leading suggestions involve the cold, the high pressure, and the ample dissolved oxygen, all of which encourage larger cell sizes and slower growth in a range of marine animals. The pattern even has a name: deep-sea gigantism, and it shows up again and again in unrelated groups: giant isopods, giant amphipods, giant sea spiders in polar and deep water, giant single cells. Something about a cold, still, high-pressure, unhurried existence favours a large, slow body over a small, quick one. Fact number 69. The deepest fish ever filmed is a small, pale, entirely unthreatening animal called a snailfish, and its story is quietly heroic. Snailfishes are soft-bodied, tadpole-shaped, usually under 30 centimetres, with loose, gelatinous skin and no scales, and they look, frankly, like something made of wet tissue paper. In 2023, a team working in the Izu Ogasawara Trench south of Japan filmed a juvenile snailfish at 8,336 metres and caught others at 8,022, the deepest fish ever recorded. There appears to be a hard ceiling, or rather a hard floor, at somewhere around 8,200 to 8,400 metres, below which no fish can go. The reason seems to be chemical. Fish stabilise their proteins against pressure using a compound called trimethylamine oxide, and the concentration required increases with depth, until at around 8¼ kilometres, the fish's internal chemistry would become more concentrated than seawater itself, at which point water floods in and the whole arrangement fails. Nature has a depth limit for backboned animals, and we have found it. Fact number 70. Below that limit, life continues perfectly well without a backbone. Sediment samples brought up from the very floor of the Challenger Deep at nearly 11,000 metres are alive with bacteria and single-celled organisms in surprising abundance, feeding on organic matter that funnels down the steep trench walls and collects in the bottom like leaves at the foot of a wall. Amphipods thrive there. Sea cucumbers of a translucent, almost ghostly kind have been filmed drifting just above the ooze. In 2020, a team recorded microbial activity in trench sediments at rates higher than in the surrounding abyssal plain, precisely because the trench acts as a funnel. The deepest place on Earth is not the emptiest. It is a collecting basin, and things that fall anywhere near it eventually arrive there, and something is always waiting at the bottom, quietly and without any fuss, to take delivery. The Thessaly is on her way up now, and the ascent is slower and stranger than the descent, because there is nothing to look forward to except a gradual blue. Ines Marchetti has the heaters on and a blanket over her knees, and she is eating a cheese sandwich she made 11 hours ago, and she is entirely happy. The water outside the window is the same water it was on the way down, and it is worth saying something about that water now, because we have spent a great deal of time on the animals and hardly any on the sea itself. The water Inyas is rising through has a history. It came from somewhere. It has a temperature it acquired in a specific place at a specific time, and it has been carrying that temperature patiently for longer than any nation on the surface has existed. It has been out of the light for centuries. It will go back into the light eventually, in a place none of us could predict, and when it does it will bring nutrients up with it and feed a fishery that somebody's grandchildren will depend on. The deep sea is not a still pond. It is a river system so slow that a human lifetime cannot see it move. Fact number 71. The great circulation of the deep ocean is driven not by wind but by density, and density in seawater comes from two things: temperature and salt. In a small number of places on Earth, both conditions line up. In the Nordic seas north of Iceland and in the Weddell and Ross seas around Antarctica, surface water becomes bitterly cold. And when sea ice forms, it leaves its salt behind in the water below, making it saltier still. Cold and salty means heavy, and heavy water sinks. It sinks in great slow sheets kilometers down, and then it begins to travel along the bottom, spreading out across the world's basins, sliding under everything lighter than itself. This is the thermohaline circulation, sometimes called the global conveyor belt, and it moves water from the poles to the equator along the seafloor, up in certain regions, back along the surface, and eventually round again. A single circuit is thought to take somewhere in the region of 1,000 years. The water beneath a ship in the tropical Pacific may last have touched the atmosphere while the Norse were building longships. Fact number 72. Because that water arrives from the poles, the deep ocean is uniformly, permanently cold everywhere in the world, regardless of what the surface is doing. Below about 1,000 meters, the temperature of the sea sits between roughly 0 and 4 degrees Celsius in almost every basin on the planet. It does not vary with the seasons. It barely varies with latitude. You can sail from the Arctic to the equator, dropping a thermometer as you go, and find the surface temperature swinging by 30 degrees while the water at 3,000 meters stays stubbornly, monotonously near freezing the whole way. This is one of the great facts about our planet that almost never gets said plainly. The ocean is a cold place with a thin, warm skin. The tropics are a decoration. The great bulk of the world's water is dark and near freezing, and it always has been. Fact number 73. The heaviest, deepest, coldest water in the world ocean is made in one place, and it is called Antarctic bottom water. It forms on the continental shelves around Antarctica, particularly in the Weddell Sea, where extreme cold and brine rejection from forming sea ice produce water so dense that it cascades off the edge of the shelf and pours down the continental slope like a submarine waterfall. It then spreads north along the very floor of the Atlantic, the Indian and the Pacific, filling the lowest layer of every basin it can reach, and it can be traced by its temperature and salinity signature as far as the northern Atlantic, tens of thousands of kilometers from where it was made. Oceanographers can point at a measurement taken off Greenland and say, with confidence, that this particular water was last at the surface off Antarctica. Nothing about it is fast. It moves at a few centimeters per second in places, which is a slow walk for a snail, and it takes centuries to make the journey, and it is one of the most consequential slow movements on Earth. Fact number 74. We can measure how long a parcel of deep water has been away from the surface, and the technique is beautiful. While water is at the surface, in contact with the atmosphere, it takes up carbon dioxide, containing a small fraction of radioactive carbon-14. The moment it sinks, that supply is cut off, and the carbon-14 begins to decay at a known and utterly reliable rate. Measure how much is left, and you have the age of the water, the number of years since it last saw the sky. The results are extraordinary. The oldest water in the world ocean is found in the deep North Pacific, and it is somewhere in the region of 1,000 to 1,600 years old. 16 centuries in the dark, moving a few centimeters a second, carrying its temperature and its salt and its dissolved oxygen, gradually being nibbled at by bacteria, drifting toward a surface it has not touched since before the fall of empires. When it finally rises off the coast of Alaska or in the Southern Ocean, and its nutrients bloom into plankton and feed a run of fish, it will be delivering a message posted a very long time ago. Fact number 75. The abyssal plains are the flattest surfaces on Earth, and the phrase is not a figure of speech. Across vast stretches of the deep Atlantic and Pacific, The seafloor has a gradient of less than 1 part in 1,000, meaning it drops by less than 1 meter over a horizontal kilometer. That is flatter than any desert, any salt pan, any frozen lake, any airfield we have ever graded. The reason is the sediment. The underlying volcanic crust is rough, broken and hilly, but the endless slow rain of marine snow has been filling in the hollows for tens of millions of years, smoothing everything, burying the landscape under a soft pale blanket hundreds of meters thick. Together, the abyssal plains cover roughly half the surface of the Earth. Half, the single most common landscape on this planet, is a cold, dark, silent, almost perfectly level plain of pale ooze, several kilometers beneath the sea, populated by sea cucumbers and worms and single cells the size of your hand, and no human being will ever walk on any of it. On the Corvina, it is a little after 2 in the morning, and the ship has settled into the particular quiet that a working vessel finds in the small hours. The generators hum. Something in the galley cupboard shifts and clinks with each slow roll. Priya Anand has gone up to the bridge with a fresh mug, and the officer on watch has the radar on standby and the deck floodlights off, and the sea outside is entirely black except for the reflection of the ship's own steaming lights moving on the water like 2 dropped coins. There is no land within 400 kilometers. There is no other vessel on the plot. Below the keel there is nearly 5 kilometers of water, and below that another few kilometers of soft sediment, and below that the young volcanic rock of the seafloor itself, and below that the slow hot interior of the planet. Priya thinks about this for a while, and then stops thinking about it, because it is the sort of thought that is better held loosely. On the surface, the ship holds station. In the water column, a small yellow submersible is rising at 0.5 meter per second and will surface a little before dawn. And beneath all of it, the floor of the ocean goes on doing what it has been doing for a very long time, which is to say making itself, moving, and quietly disappearing again at the edges. Fact number 76. There are mountains under the sea, and there are far more of them than there are on land. A seamount is an underwater mountain, usually volcanic, rising 1,000 meters or more from the seafloor without breaking the surface, and satellite mapping combined with ship surveys suggests there are more than 100,000 of them, with smaller undersea hills numbering in the millions. Only a tiny fraction have ever been visited. Each one is an island of complexity in an otherwise flat world. The currents striking a seamount are deflected upward, carrying nutrients with them, so that the summit and flanks are often crowded with cold water corals, sponges, crinoids, and dense aggregations of fish that gather there to feed and to spawn. Because they are isolated from one another by hundreds of kilometers of featureless plain, seamounts can develop distinctive local communities, and a survey of a previously unvisited peak very frequently returns species that are new to science. There are mountain ranges down there that no eye has ever seen, with their own gardens on top. Fact number 77. The longest mountain range on Earth is entirely underwater, and it runs almost all the way around the planet. The mid-ocean ridge system is a continuous seam of volcanic mountains, roughly 65,000 kilometers long, that snakes down the middle of the Atlantic, around Africa, across the Indian Ocean, and up through the eastern Pacific. It is where new seafloor is made. Along its crest, the plates of the Earth's crust are pulling apart at a rate of a few centimeters a year, and molten rock rises to fill the gap, cools, and becomes new ocean floor, which then spreads slowly outward in both directions. Everything we have talked about, every vent field, every plain, every trench, is downstream of this one enormous slow seam. It is the largest single geological feature on the planet. It produces most of the volcanic activity on Earth by volume, and almost nobody has ever seen a meter of it. Fact number 78. Scattered across large areas of the abyssal plain, lying half buried in the ooze, are dark, lumpy stones the size of potatoes. They are called polymetallic nodules, or manganese nodules, and they are made of metals, chiefly manganese and iron, with useful traces of nickel, copper and cobalt that have precipitated out of the seawater and the sediment pore water in concentric layers around a tiny nucleus, often a shark's tooth or a fragment of bone or a grain of sand. They grow at a rate that is difficult to hold in the mind. A typical nodule adds between 1 and 10 millimeters of new material every million years. A nodule the size of your fist may have been growing since before the earliest primates. In parts of the Pacific, they carpet the seafloor in the millions, and each one is a small hard island in a soft world, providing the only firm attachment point for sponges, corals and anemones for kilometers around, so that the animals living on them are found nowhere else. Fact number 79. Those nodules are, as of the mid-2020s, the subject of the deep sea's one genuinely urgent argument, and it deserves to be stated calmly. The metals in them are useful for batteries and electronics, and several companies wish to collect them at industrial scale from the seafloor of the Central Pacific. The difficulty is that the nodules are themselves habitat, that the sediment they sit in is the accumulation of tens of millions of years, and that recovery from disturbance in the deep is measured in decades or centuries rather than seasons. A small experimental plough track cut into the seafloor off Peru in 1989 was revisited nearly 30 years later, and the tracks were still clearly visible, and the community living in them had still not returned to normal. That is the essential character of the deep. Everything is slow, and slowness cuts both ways. It grants stability, and it means a scar keeps. Fact number 80. Here is a fact about the seafloor that reorders your sense of the planet. The continents are ancient. There is rock in Canada and in Western Australia older than 4 billion years, more than 9/10 of the age of the Earth. The ocean floor is not like that at all. Because new crust is constantly being made at the mid-ocean ridges and constantly being destroyed where it slides back down into the mantle at the trenches, the seafloor is continuously recycled, and almost none of it is old. The oldest ocean crust anywhere on Earth in a small patch of the Western Pacific and another off the coast of northwest Africa is about 180 to 200 million years old. Everything else is younger, which means that while the deep sea feels like the oldest and most changeless place on the planet, the floor beneath it is, geologically speaking, brand new. The abyss is ancient in mood and young in fact, and it is quietly remaking itself, a few centimeters a year, while everything above it sleeps. Everything we have said so far, every number and every creature, arrived in the world the same way somebody wanted to know, and went and looked and wrote it down. That is worth a few minutes of its own, because the history of getting down there is a very human story of rope and glass and nerve, and a great deal of patience. It begins with people leaning over the side of wooden ships with a weight on a line, and it ends, so far, with a woman in a small white sphere eating a cheese sandwich at 3 kilometers, and it is not finished. Fact number 81. The modern study of the deep sea begins with a single voyage. In 1872, a converted British warship named the Challenger set out with a scientific party aboard, and over the following 3.5 years she sailed almost 70,000 nautical miles, crisscrossing every ocean except the Arctic. At station after station the crew stopped the ship, lowered weighted lines to measure the depth, dredged the bottom, took temperatures, and sampled the water. It was tedious, cold, wet, endlessly repetitive work, and it produced the foundation of an entire science. They made 492 deep soundings, sampled the seafloor at hundreds of sites, and brought home roughly 4,700 species previously unknown to science. The final report ran to 50 volumes and took 19 years to publish. They also, in 1875, sounded a spot in the Western Pacific that came back far deeper than anything else they had found, and the deepest point on Earth carries the ship's name to this day. Fact number 82. For the next 50 years, nobody actually went down. Everything was known from things hauled up dead. Then in 1930, a naturalist and an engineer climbed into a hollow steel ball a little under 1.5 meters across, with 3 small windows of fused quartz. and had themselves lowered on a cable off Bermuda. The device was called a bathysphere, and it had no propulsion, no escape hatch, and no way home except the cable. Over several seasons they went progressively deeper, eventually reaching just over 900 meters in 1934. The naturalist spent the descents with his face pressed to a window, describing what he saw over a telephone line to a stenographer on the ship above, and what he described was a world nobody had imagined: black water full of lights, creatures flaring and pulsing past the glass, an ocean that was not empty, but crowded and luminous. Much of it was too fleeting to name, and some of it has never been convincingly identified. He was the first person in history to look at the deep sea and see it living. Fact number 83. 30 years later, in January of 1960, a very different vessel went all the way. The bathyscaphe Trieste was essentially a small pressure sphere slung beneath an enormous float filled with petrol, which is lighter than water and crucially does not compress. With 2 men aboard, it descended into the Challenger Deep and settled on the bottom at just under 11,000 meters. The descent took nearly 5 hours. On the way down at around 9,000 meters, one of the outer window panes cracked with a bang that shook the whole vessel, and the 2 men discussed it briefly and decided to continue. They stayed on the bottom for about 20 minutes in a cloud of silt their own landing had raised, and reported seeing a flatfish-like creature move away across the ooze, an observation that has been debated ever since. Then they dropped their iron ballast and rose for 3 hours and 15 minutes. Nobody returned to that spot for 52 years. Fact number 84. The workhorse of deep-sea science, though, is a small, unglamorous, endlessly modified submersible named Alvin, which entered service in 1964 and is still diving today. Alvin carries a pilot and 2 scientists in a titanium sphere just over 2 meters across, and over 6 decades it has made more than 5,000 dives. It found the hydrothermal vents. It surveyed the wreck of a famous liner. It once recovered a lost hydrogen bomb from the seabed off Spain. It sank at the surface in 1968 when its lifting cables failed, and was recovered a year later with the crew's packed lunches inside, soaked and cold but essentially unspoiled, which turned out to be an accidental and rather important experiment in how slowly things decay in the deep. Every component of the vehicle has been replaced at least once, so that Alvin today is a philosophical puzzle as much as a machine, and after an upgrade completed in 2022, it can now reach 6,500 meters, which puts almost the entire ocean floor within its range. Fact number 85. Most deep-sea work today is done without any people in the water at all. A remotely operated vehicle, and ROV, is a robot on a tether, connected to the ship by a cable carrying power down and data up through optical fiber. It can stay down for a full day or more. It can be operated in shifts by a whole team. It carries better cameras and more sample containers than any crewed submersible. And if something goes badly wrong, the loss is measured in money rather than in lives. A modern working ROV is the size of a small van, brilliantly lit, festooned with instruments, and equipped with hydraulic manipulator arms delicate enough that a skilled pilot can pick a single soft jellyfish out of the water without damaging it, or unscrew a bolt, or place a marker beside a coral colony to find it again in 5 years. Its video is broadcast live in some programs, so that anybody with a screen can sit at home and watch a piece of seafloor that no eye has ever seen before, in real time at 3 a.m, along with a few hundred strangers and a couple of very excited scientists narrating from the control van. There is one more thing worth saying about how we learn what is down there, and it is the least technical item on this whole list. Almost everything in deep-sea science is found by accident, by people who were carefully looking for something else and had the presence of mind to stop and pay attention. The hydrothermal vents were found by geologists on a rock survey with no biologist aboard. The deep scattering layer was found by naval sonar operators who thought their instruments were broken. The transparent-headed barrel eye was known for half a century as a fish with a hole in its skull, because every specimen arrived crushed. until somebody happened to film a living one from a submersible on an unrelated dive. The glass sponge reefs off Canada were found by geologists mapping sediment. Whale falls were discovered when a submersible pilot, transiting between two survey sites, noticed something pale on the seafloor and diverted for a look. The reason this happens so consistently is simple arithmetic. The deep sea is so large, and our coverage of it so thin, that essentially every hour a vehicle spends down there is spent somewhere no vehicle has been. You cannot plan to find what nobody knows exists. You can only be in the water, with the lights on and the cameras rolling as often as possible, and be the sort of person who stops the survey and turns the vehicle around. Which means, pleasantly, that the qualification for making a genuinely new discovery about our own planet is not brilliance. It is attendance, and attention, and a willingness to be surprised at 3 a.m. at the end of a 14-hour shift. There is a version of this available to almost anybody. Live video feeds from research vessels are streamed publicly during many expeditions now, and the comment channels are read by the science teams. Members of the public watching those feeds at home have flagged animals the scientists had missed, correctly identified species from the deck of nowhere, and on more than one occasion been thanked in the resulting paper. Somebody sitting in a kitchen in the middle of the night, watching a robot crawl across a seamount on the far side of the world, is part of the survey. That is a genuinely new thing in the history of exploration, and it is quietly one of the nicest developments of the past 20 years. On the Corvina, none of this is being streamed, because it is a small ship on a modest budget doing unglamorous work on a vent field that will produce 3 papers and no headlines. But the principle holds. 11 hours ago, Inez Marchetti went down to collect samples from a chimney that has been catalogued and revisited for a decade, and at some point during the dive she passed something on the flank of the ridge that she does not recognise, and she stopped, and she filmed it for 4 minutes, and she will send that clip to a colleague who will send it to another colleague. And in a year or 2, it may have a name. Now let us look at the machines that make all of this possible. Fact number 86. Not every robot needs a cable. An autonomous underwater vehicle carries its own power and its own instructions, is released from the ship, and simply goes, following a programmed track for hours or days before returning to a rendezvous point. The most patient of them are not powered by propellers at all. An underwater glider has no engine. It changes its own buoyancy slightly, sinking and rising, and a pair of small fixed wings converts that vertical motion into forward motion, so that the vehicle soars its way through the ocean in a long, shallow zigzag at the speed of a leisurely swimmer. Because it spends almost nothing, a glider can stay at sea for months. Several have crossed entire ocean basins unattended, surfacing every few hours to send their data home by satellite, and to ask, politely, whether anyone has new instructions. There is something lovely about the idea of a small yellow machine spending a whole winter alone in the North Atlantic, rising and falling and rising again, measuring temperature and salinity in the dark, and calling home each morning. Fact number 87. The single largest ocean observing system ever built consists of several thousand floats drifting freely in the world's oceans, and it has been running since the early 2000s. Each float is about the size and shape of a fire extinguisher. Left to itself, it sinks to a parking depth of around 1,000 meters and drifts with the current for 10 days. Then it adjusts its buoyancy, descends to 2,000 meters, and rises slowly all the way to the surface, measuring temperature and salinity the whole way up. At the top, it transmits its profile to a satellite, and then it sinks again and repeats for 4 or 5 years until its batteries run down. There are around 4,000 of them out there tonight, and between them they return over 100,000 vertical profiles of the ocean every year. Before this fleet existed, our picture of what the deep ocean was doing came from ships, and ships mostly go where people need to go, in seasons when the weather is tolerable. Now the ocean measures itself continuously in every basin, including in the middle of the Southern Ocean in winter, where no sensible ship goes at all. Fact number 88. The cheapest, and in some ways the most productive deep-sea instrument, is a lump of metal that falls to the bottom on its own and comes back when asked. A baited lander is a simple frame carrying lights, a camera, a chunk of bait, sometimes a trap, and a heavy weight. It is dropped over the side, it free falls for a few hours, and it sits on the seafloor filming whatever comes. When the scientists want it back, they send an acoustic signal, the lander releases its weight, and a set of glass or syntactic foam buoyancy spheres carries it to the surface, where it floats and flashes and waits to be found. Most of what we know about Hadal scavengers, about the deepest fish, about how quickly the abyss can assemble a crowd, comes from these unglamorous frames. They require no cable, no submersible, no pilot, and only a modest ship. They are the deep sea's version of leaving a camera and a sandwich in a wood overnight, and they work just as well. Fact number 89. Keeping anything alive or functional under 1,000 atmospheres is an engineering problem with only a few good answers, and the deep-sea community has settled on all of them. Crude spheres are made of titanium, forged and machined to extraordinary tolerances, because a sphere distributes pressure evenly, and titanium is strong and does not corrode. Windows are thick cones of acrylic, cut so that the pressure pushes them more firmly into their seats, meaning that the deeper you go, the better the seal becomes. Electronics live in oil-filled housings, because oil does not compress meaningfully, and so the pressure inside matches the pressure outside, and nothing has to hold anything back. And buoyancy is provided by syntactic foam, a solid material made of millions of tiny hollow glass spheres set in resin, which is light and rigid, and unlike any gas, refuses to be squeezed. A modern deep submersible is essentially a titanium ball wearing a block of glass-filled foam like a hat, looking out through a plug of plastic that is held in place by the very thing trying to crush it. Fact number 90. The newest tool of all requires no camera, no lights, and no submersible. It is a bottle of water. Every animal in the sea constantly sheds traces of itself, in mucus, in scales, in waste, in shed cells, and those fragments of nard drift in the water for hours or days before they degrade. Collect a few litres of seawater from a given depth, filter it, sequence what is on the filter, and compare the results against reference libraries, and you obtain a list of the species that have recently been present. This is environmental DNA, and it has already found animals in places nobody had recorded them, detected rare and shy species that avoid vehicles, and revealed that the twilight zone is considerably more diverse than net sampling suggested. It is limited by the reference libraries, of course. A sequence with no match in the database tells you only that something was there and that nobody has ever named it. In the deep sea, that happens constantly, which is a rather wonderful sort of problem to have. Dawn is coming up on the Corvina, though there is nothing to see of it yet except a thinning at the eastern edge of the sky, the black going to charcoal, the charcoal going to a dull tin colour. Priya Anand is on deck in a borrowed jacket, watching the water for a yellow shape. Tobias Lund has taken off his headphones for the first time in 9 hours and is standing beside her, saying nothing. Somewhere below, the Thessaly is at 80 metres and rising. Anines Marchetti has switched her exterior lights on for the last part of the ascent, out of habit, and is watching the water outside her window turn from indigo to navy to a soft grey blue that means the world is about to start again. 15 facts to go, and then all of us can sleep. Fact number 91. Somewhere between 1 and 2,000 new marine species are formally described every year, and a substantial proportion of them come from deep water. This is not a burst of activity following some new discovery. It is the steady, unremarkable annual rate, and it has been running at roughly this level for decades. Each one represents an animal collected or photographed, compared against everything previously known, drawn and measured and dissected, given a name in Latin, and published. The bottleneck is not the ocean. The ocean supplies material faster than anyone can process it. The bottleneck is the number of taxonomists in the world, which is small and not growing, and the number of hours in their days. There are museum drawers in a dozen countries containing specimens that have been waiting patiently since the 1970s for somebody with the right expertise to open the jar and give them a name. Fact number 92. The best estimates suggest that the majority of the deep sea's animal species have never been described at all. The proportion is genuinely uncertain, and honest researchers give wide ranges, but studies that sample a patch of abyssal seafloor thoroughly and then count how many of the species found were already known routinely report that most were not. In some abyssal surveys, particularly in the Central Pacific, the figure has come out well above 80% unknown. Not unknown to the survey team, unknown to science, entirely, with no name and no published description anywhere on Earth. Which means that if you were to lower a net into a randomly chosen patch of abyssal plain tonight and haul it up, the chances are excellent that something in it would be new. Not rare, not exotic, just never previously written down, in a place we have never previously looked, of which there are a very great many. Fact number 93. The deep ocean is where the planet keeps its heat. Of all the extra energy trapped in the Earth system over the past half-century, something in the region of 90% has gone into the ocean rather than the air, and a growing share of it has worked its way down below 700 meters. Water has an enormous heat capacity, far higher than air, and the sea has been quietly absorbing an amount of energy that would be catastrophic if it had stayed in the atmosphere. That absorption is why the surface world has warmed as slowly as it has. It also means the change is banked rather than avoided, because the deep releases heat as reluctantly as it takes it, over centuries. If you want a single image for it, think of the ocean as an enormous slow flywheel, hard to spin up, and once spinning, almost impossible to stop. The deep sea has been protecting the surface for a long time, patiently and without comment. Fact number 94. In 1987, surveying the seabed off the coast of British Columbia, geologists found something the textbooks said should not exist. Rising from the muddy floor of the strait were great mounds, some of them up to 20 meters high and several kilometers long, built of glass sponges growing on the skeletons of their own dead ancestors. Reefs of this kind were known from the fossil record, from a vast belt that stretched across the shallow seas of Jurassic Europe, and every authority agreed that they had disappeared around 40 million years ago. They had not. They had simply moved into deep, cold, quiet water where nobody had thought to look, and continued growing, slowly, for 9,000 years since the last ice age, building glass upon glass in the dark, while the world above forgot about them entirely. Fact number 95. Not everything remarkable in the sea is small or hidden. For centuries, sailors reported an event so improbable that it was regarded as folklore, the Milky Sea. A ship would sail, at night, into an area where the entire ocean surface glowed a steady, even, whitish blue from horizon to horizon, without waves or sparkle, like sailing across a field of snow under moonlight. Accounts described it lasting for nights on end and covering thousands of square kilometers. There was no mechanism anyone could believe, and no photograph. Then in 2005, researchers went back through satellite records of low-light emission and found one, a patch of glowing ocean off the Horn of Africa, roughly the size of a small country. That persisted for 3 consecutive nights in 1995, exactly where a merchant ship's log had recorded sailing through a Milky Sea. It is thought to be caused by luminous bacteria in astronomical numbers, and unlike the flashing of plankton in a boat's wake, it does not blink. It simply shines steadily, all night, over an area you could not cross in a day. 5 left. Let your eyes close if they have not already, because there is nothing more to picture that you have not already pictured, and the last few are the quiet ones. Before them, one small thought to carry down with you. It is easy to hear a list like this and file the deep ocean under things that are far away. It is not far away. If you live near any coastline on any continent, the edge of the deep sea is closer to you than most of the places you drive to. The continental shelf runs out somewhere between 50 and 200 kilometers offshore in most of the world, and at its edge the seafloor tips over and falls away, and within another few tens of kilometres you are over water 2 or 3 kilometres deep. From a coastal town, the midnight zone is an afternoon's sailing. It is nearer than the next large city. It is nearer in many cases than the nearest mountain, and it is connected to you in ways that are entirely unromantic and entirely real. The oxygen in the breath you are taking now was, for roughly every second breath, produced by microscopic organisms in the sea. The weather that will decide what you wear tomorrow was assembled over the ocean and steered by the heat it holds. The rain that fills the reservoir your tap draws from evaporated off a surface that sits above 4 kilometres of cold, dark water. The carbon from a journey you took last year is, in a small fraction, already on its way down through the twilight zone inside the bodies of animals that will never know they carried it. There is no boundary anywhere in this system. There is only a very large, slow reservoir and a very thin, fast surface, and we live on the surface and are kept steady by the reservoir. So when people call the deep sea alien, I understand what they mean, and I think they have it slightly the wrong way round. It is not that the deep is a strange world attached to our own. It is that the deep is the main body of the world, and the sunlit part where we happen to live is the strange, thin, unusually eventful margin of it. 95% of the living space on this planet is dark and cold and calm. The bright noisy bit is the anomaly, which means, if you like, that lying in a dark quiet room at the end of a long day, doing very little, unbothered, waiting patiently for something good to drift down to you, is not an unusual state at all. It is the ordinary condition of almost everything that is alive. Now, 5 facts, and then we will go back down one last time together, slowly, and I will leave you at the bottom. Fact number 96. The deep sea has no weather, and this is perhaps the most restful fact in this entire list. Below about 1,000 metres there are no storms. There is no wind, because there is no air. There are no waves, because waves are a surface phenomenon and they die out within a wavelength or 2 of depth. Even the largest storm swell in the North Atlantic is entirely undetectable a couple of 100 metres down. There is no rain, no snow except the slow organic kind, no lightning, no fog, no frost, no heat wave, no drought. The temperature at 4,000 metres in the mid-Pacific this evening is within a fraction of a degree of what it was last evening and of what it will be next century. The salinity is the same, the pressure is the same, the darkness is exactly, precisely the same as it was yesterday and as it will be in 1,000 years. It is the most stable large environment on the surface of this planet, and nearly every animal that lives there has been shaped by that stability into something slow, long-lived and unhurried. Fact number 97. It is also, contrary to expectation, not silent. The deep sea has a constant low background sound made of things that never stop, distant storms transferring their energy into the water column, the grinding of the seafloor as plates shift, rain falling on the surface hundreds of kilometres away, the low hum of the planet itself. Hydrophones left on the seabed for months record all of it, and through that steady wash come the individual voices, the clicks of sperm whales, which sound like a carpenter tapping a nail, the long descending moans of fin whales, the squeaks and creaks of ice at the poles, travelling thousands of kilometres, the crackle of shrimp on a distant reef which sounds like fat in a hot pan, and, increasingly, ships, the low steady drone of propellers, from everywhere, all the time. What the deep sounds like, if you sit and listen to a recording with your eyes closed, is a very large room with a fire in it, and weather somewhere far off outside. Fact number 98. Of that enormous, stable, quietly humming world, we have laid eyes on almost none. The figure most often quoted is that humans have directly observed something like 0.1% of the deep seafloor, and a study published in 2025, which pulled together the records of every deep submergence dive ever logged, put the visually observed area of the deep seabed at a fraction of a percent, roughly equivalent in area to a small country. spread out in thin scattered ribbons across a surface that covers most of the planet. Almost all of that observation is clustered near a handful of wealthy coastlines. Enormous regions, whole basins, have never had a camera lowered into them at all. When we say that the deep ocean is unexplored, we do not mean that the map has some blank corners. We mean that we have walked a few footpaths across a continent at night with a torch and drawn what we saw and called it a survey. Fact number 99. Everything in this list is happening right now. That is worth saying slowly, because it is easy to hear facts about the deep sea as history, as something recorded and finished and filed. It is not. At this exact moment, while you are lying still in a warm bed, the snow is falling through the midnight zone in every ocean, in perfect silence. The great nightly migration is underway somewhere on this planet, as it always is, billions of small animals rising toward a surface they will leave again before morning. A sperm whale is holding its breath at 900 meters. A tube worm on a vent field is waving its red plume in warm water. Somewhere in the North Pacific, a parcel of water that last saw daylight in the 6th century is a few centimeters further along its journey than it was when this recording began. None of it needs you awake. All of it will keep going while you sleep. Fact number 100. And here is the last one, and it is the gentlest. A single flake of marine snow that formed at the surface tonight, out over some deep basin, will take somewhere between a few weeks and a year to reach the abyssal plain below. It will fall the whole time, without stopping, without any effort of its own, turning slowly, catching light that isn't there. It will pass through the twilight zone while you are sleeping, and through the midnight zone while you are getting on with your week, and it will still be falling on a day some months from now when you have entirely forgotten this video, and the name of the ship, and every number in this list. And then, one ordinary afternoon that means nothing to anyone, it will settle, without a sound, onto pale ooze that has been accumulating for 60 million years. And it will become part of the floor. Nobody will see it. Nobody needs to. That is the deep ocean's whole way of being. Enormous, patient, unwitnessed, entirely unbothered, and quietly holding up everything above it. The Thessaly broke the surface at 4 minutes past 6, and Priya Anand saw her first, a yellow shape lifting on a grey swell 50 meters off the starboard quarter, and she called out and pointed and did not manage to sound professional about it at all. The crane swung. The swimmers went out in the little boat. The hatch opened, and Ines Marchetti climbed out into the first proper daylight she had seen in 14 hours, blinking, stiff, smelling of cold metal and coffee. And the first thing she said, before anything about the vents or the samples or the depth, was that it had been a good dive and that she was going to have a shower and go to bed. And that is 100. If you are still with me, there is no need to do anything now except stay exactly where you are and let the last of it settle. Let me take you back down one more time, slowly, without any facts attached, so that the shape of it is the last thing in your mind. Start at the surface on a calm night, with the water black and glassy and the swell lifting and lowering you very gently, the way a hand rocks a cradle it has rocked 1,000 times. There is a ship somewhere behind you with its lights on. Now down. The first 10 meters and the red goes out of the world. The reds go, and then the oranges, and everything begins to turn the colour of an old photograph washed in blue. 30 meters. 60. The blue is deepening, and the surface above you is a bright ceiling with a texture to it, moving 100 meters. And the ceiling is a soft grey-blue glow, with no shape at all. 200, and you have crossed the line, though there was no line. This is the beginning of the deep, and there is still light here, but it is only a memory of light. 400 meters. The twilight zone. Look up, and there is a faint, even, blue-white glow. Look down, and there is nothing at all, which is not frightening, only very large, Small silver fish are hanging around you in the dark, each with a row of tiny lights along its belly, glowing gently downward at exactly the brightness of the water above, so that they disappear from beneath. 600 meters. A jellyfish drifts past, red as a plum, invisible in this light to everything but you. 800, the last photon of sunlight anyone has ever measured, is somewhere around here, and after it there is nothing more from the sun. Forever. 1,000 meters. You are in the midnight zone now, and it is the largest single living space on Earth, and it is entirely, permanently dark, and it is full of light. Blue sparks come on and go off in the distance, and none of them are for you. Somewhere off to the side, a small fish with a lantern on a rod in front of her face is hanging perfectly still, and has been for hours, and will be for hours more. A soft red animal with blue eyes and a cloak is trailing 2 long sticky threads and gathering dust. The snow keeps falling past you, unhurried, catching the light of things that are not looking at you. 1,500 meters, 2,000, 3,000. The pressure outside is now 300 times what it is in your bedroom, and it does not matter, because there is nothing in you that it can squeeze. A sperm whale passes somewhere below, clicking steadily, and you feel the clicks more than you hear them. 4,000 meters. The floor comes up out of the dark, softly, and it is pale, and it is flat, and it goes on further than any desert. Sea cucumbers are scattered across it like plums on a bedsheet. A herd of small pink sea pigs is walking, all facing the same way, following a smell. A single cell the size of your hand has built itself a rosette out of sand grains, and small animals are living inside it. Somewhere over the horizon there is a whale skeleton with red flowers growing out of the bone, feeding a village of creatures that will still be there in 40 years. Off to the west, a field of chimneys is putting out warm mineral water in the dark, and a crowd of blind furred crabs is slowly waving. There is no wind here. There is no sound but a low hum. There is no season and no morning. The temperature is 2 degrees, and it was 2 degrees yesterday, and it will be 2 degrees in 100 years. Now let all of that stay exactly where it is, and come back up, slowly, without looking at any of it. 4,000. 3,000. 2. 1. Through the twilight, past the silver fish and their little rows of lights, up into the blue, up into the grey, up into the first faint suggestion of a surface, and out. Take a slow breath in, and let it go, and let your jaw unclench, and let your shoulders drop away from your ears one more time. There is nothing left to do tonight. Everything down there will carry on without you, exactly as it has since long before anyone thought to look, and it will still be going tomorrow, and the day after, and for a very long time after that. The snow will keep falling, the lights will keep coming on and going off in the dark, the water will keep making its slow 1,000-year circuit of the world, cold and patient and entirely indifferent to how your week has gone. There is a great deal of comfort in a thing that large and that calm and that unbothered. You do not have to hold any of it. You do not have to remember any of it. If you woke up at some point in the middle and lost the thread, that is exactly what this was for. Thank you for spending part of your night down here. Sleep well and rest easy, and if you would like to come back and do this again, the deep will not have changed in the slightest, which is more than can be said for almost anything else. Good night.